Looks like Girish, we have everyone now because I can see number of participants is 30.
Hey, Shivang. Good morning, Shivang. Satish here. Yeah, I think we have all the participants. We can start the session, Shivang.
Perfect. Great. Let me just share my screen also.
Sure.
Okay, guys, can you quickly confirm if you can see my screen having a whiteboard where I'm sort of writing welcome?
Yeah.
Yeah, sure, we can see.
Awesome. So hello guys, this is Shivang. I will be your host for this particular whole training. So first of all, welcome to this big data component. And let me put some context and my introduction before we start on anything so that we have the right set of expectations with it. So first of all, this training is going to be highly interactive. So this, I would be surely expecting all of you to be interacting with me quite a lot. So you can unmute yourself at any time. By default, keep yourself on mute just to ensure that we do not have any background noise. But other than that, whenever you want to talk, just unmute and start talking. There is no restriction on that. Secondly, about myself, myself Shivank, and basically I have done my education from IIT Chennai Computer Science, and I have worked with various companies like starting with Oracle. I have also worked with Microsoft in Mobi. And then I started my own firm, which is again into data science and big data domain. And right now I'm doing consultancies with multiple companies. To name few big ones right now, I'm like Facebook London is also one of my client, which is also a consultant. I'm also working right now with Oracle as a consultant as well, along with few more bigger firms as well. I have sort of published till now 4 international research paper. I was the only Indian to have get awarded in Greece for one of the research paper at that particular time. Even in open source contribution, you will find my name a lot. Even you can easily find it on Wikipedia, also mentioned as one of the major contributor to some open source community sites, especially like in our consortium. You can even look at that on my name on the top contributor there. Along with that, this training is something which is my hobby. I love talking and kind of spreading my own knowledge. So most of the component which you will be finding in this training will be also coming from my experience as well. So there will be few case studies which I'm going to introduce in the classes, which you will find it very much related to how in the real world you will be getting the project, because the intention is not to just get you into the client zone, but the motivation is that once you complete the training and you go to your client location, they should say, wow, right? So that's the whole idea. So you should be able to also excel in that. So what kind of challenges will come in when you will be working on this? So that's where we will go a little advanced. We will see that what are the real challenges come, which you may not find in books around easily, but these comes mainly from experience. Along with that, there may be few case studies which I may ask you to work on your own. But given that this training is on the day-to-day daily basis, and then definitely after that you will have a lot of work of office as well. So I assume you may not get time. So few of the case studies or assignments I will be expecting you to do in the class itself. So the way it's going to happen is I'm going to break you out into some rooms. So I can see, let's say there are 30 candidates, so maybe 4 or 5 people in one group. And you will be going into a group, and myself and Lakshmi will be keeping an eye on all the groups. You will be discussing just like how, let's say you get into a team and start working on a client side, so that you get also that experience. And then basically you have to solve that particular case study. So I will be walking in few of the rooms. Similarly, Lakshmi will also be doing the same thing, and we will keep a track where you are. If you're stuck, we can help you out. And by the end, then I will present a solution to you that how we should actually be solving that particular part. So this is the slight approach we're gonna take. And at the same time, this is going to be heavily in line towards more the practical aspect. Definitely the first class is going to be more theoretical because you need to really understand the architecture of Hadoop before we even jump into anything. And I want to really spend some time to get to the nitty-gritty details of it, because if you want to talk about optimizations, then this knowledge is very much required. And secondly, I believe that since you all will be going to your client location, so there may be some sort of interview happening that will help you, because I also work like a consultant. So when I say that I work for Facebook, so Facebook have also interviewed me and my team for that. Uh, So that way I have that experience that what generally the clients look for, I will be even talking from that perspective so that you get that help as well, that how exactly, what are the client expectations. And once you go out of this training, you should definitely do well versed with this, all this part. Um, I will be sharing maybe a Google Drive link with all of you just to ensure that all the materials which we will be using in the session, you have everything with you and you need not face any trouble like asking Lashmi or anyone outside. I believe all of you will have the access to the Google Drive anyway. So you can just start using from there as well. Now, just one more thing is that I have, since I'm also kind of creating a lot of contents across to multiple places, as well as recently, I was also working with Cloudera. I have sort of written a book for them. You may find some snapshot in the class as well, which soon, should be soon published over the session as well, means with Cloudera side. And I will be showing across some snapshot of it. I cannot definitely share the whole book because there is some NDA agreement which I have to also follow, but you will still be seeing some diagrams and sometime you may see even the full-fledged book, but it will be just, I will be showing you up, but cannot upload it on the Google Drive. Um, so yeah, this is the thing we're gonna go over with. And in the start of the things, there will be three major components we will be covering. Number one, we will be talking about the Hadoop component, which is your normal map reduce aspects of the things. We will also be talking about some data ingestions. For example, we will be covering about Scoop. What is this? If you do not know, really do not bother. We will go into depth and around all this topic. Then after that, we will be also talking about, so let me write Scoop first. Then we will also be talking about Apache Hive. We will also be covering a NoSQL DB, which is going to be HBase, so that you get an insight that when you should be actually looking forward for a NoSQL DB instead of talking with RDBMS. Especially if you're working with big data, you should really be well versed with this because this NoSQL DB is really important. Now, within NoSQL DB, there are a lot of components like we have Cassandra, HBase, MongoDB. So we will be covering one, but at the same time, feel free once you get an insight on this HBase, it's very simple to get to know other DBs as well. Then the second portion, we will be moving to the other components, which is going to be your PySpark, which is your Apache Spark component. Here, we will also be covering some portion with Scala as well, because sometimes you may come across situations where your client may say, hey, I'm basically looking for, or my older code is written already in Scala or Java. So I would still try to keep it more language neutral, but at the same time, it will be a mix of both. So you may find me sometime, I will explain you with Scala, but I can give you a code in PySpark also so that you can go back and read it. Or I can do a vice versa. Anything is fine. Now, within this part, we will be covering majorly on Spark Core. We will be understanding and spending good time over it. We will be looking at Spark SQL. Again, a very important component to understand. And we will be spending a good time over basically with Spark SQL. Then we will be also spending some time, not very good, but some time on Spark streaming component and all. So we are not going to take very deep dive into it, but still we will hover over it to understand how it works. And at the end, we will also be talking with respect to Kafka. This is going to be a third major component, which we are going to also talk in detail, understanding how we send the data from a source to the same side. And also we will be spending some time to understand that how we can create even some pipelines to send across the data. So more, you can say it's going to be much more related to understanding that how you can connect various components. And that component is called as Kafka Connect. And so this is going to be at a very high level picture. There will be still some more topics around to it, but this is at a very high level. These are the things we're going to cover. Now, what you can expect in day one, starting. So before every session, I will be talking about this, that what all things we're going to be covering up in today's session so that the expectation is very clear that what all we're going to talk about. We may not be able to complete all the topics depending on the number of questions being asked. And maybe at some topics, I need to spend a little more time. I may go a little more advanced also. So that can spill over to the next day, but that's completely fine. But in day one, we will be talking about majorly what is your big data component. We will be talking about all the architecture sides. Like we will be also referring to a lot of things within it, like what is SDFS, how it works. We will do a lot of practicals insight with it. Now, even when I say practical insight, I will be giving you one Cloudera instance, which I will upload it on a Google Drive. It's going to be some 5.6 GB file. I will tell you how to load this up and how you can work with it. Second will be the cloud environment, which you will also be getting. I believe you must have all received your credentials. If you don't want to do any hard work, that's more easier way to go for. But it's just that if you use that Cloudera VM, then you can do it as long as you want. So there's no restriction with it. So you can do both the ways. I will explain you both the ways how to write the code. So we will be majorly focusing on HDFS. This is going to be the major focus today, but we will be talking about all the architecture, like how we write the data, how we read the data, how basically this name node system works within it. All the Hadoop components, what are required, we will be talking about that. If the time permits, which looks unusual, but still if the time permits, we will also be starting on Scoop. Okay. Otherwise, Scoop will be moving towards tomorrow. And in Scoop, we will hit our first case study. Okay, and I can tell you this is going to be a tricky case study, not that straightforward. You will spend some good time on it. I will give you a very huge amount of data, and there will be a lot of challenges in it. Like the data will not be clean, and there will be a lot of issues within that. So anyway, we will be solving one particular case study after understanding the whole scoop, which will give you a complete flavor and the confidence that even when you get the data from the real world, how you can deal with it. Because in real world, unfortunately, we don't get the better side of the data. That's the biggest challenge with it. So this is going to be the agenda for today. First of all, any questions or anything which you have before I start the session?
Nothing from our end. We are good, so I can start.
Okay, then we are good.
Hey, one thing, Shivang, Satish here. To that point to the groups, right? We already created some groups to make sure that we follow up, right? So Girish, can you forward that groups that we created to Lakshmi and Shivang? So us also will follow the same groups.
Yeah, okay.
Okay, so the way we are going to create a group within Zoom, we have this functionality. For example, I can see there are some 34 candidates right now sitting. So I'm assuming that 30 of the candidates will be as a learner here. And maybe I think one Satish, you are there who will be just joining in and joining out. So for those 30 candidates, we were thinking to have it like in a random way, because I want the every time a different team person to be interacting with each other.
Got it. That's fine.
Because while working with the client, you never know, maybe they have their own engineers as well. So yeah. It's good to work across with a different way.
Sure. Sure. Yeah.
Now, so let's start. So before we talk about anything, because we are sitting in this big data class, can you tell me what is your understanding about this term big data? Let's start with a very basic thing. You can use your chat box also, guys, if you're not comfortable in talking, though I would prefer that. But in case if you want to use the chat box, it's open in front of me. I can also look at that and can answer you as well. So can you answer me what is your inference from this big data? Guys, I need to be this session, I want you to.
Yeah, sure. Like the big data term itself, self-explanatory. The big means the data is very huge, that which cannot be handled by the processors which we were using previously. So that much amount of data is coming and sitting. So the challenge would be like how to store that and how to process that. That's what the big data term is.
So one key term I got is
huge.
When it comes to processing and storing, then how to work with that. Perfect. Can I get some more answers from somebody else? Your name is G House, by the way, anyway?
It's Gauss.
Okay, Gauss. Sorry.
That's okay.
So one answer I got this. Can anybody who wants to add something to this?
So in the year 2009, I believe, there was sudden outburst of data due to social media and other platforms. So in order to handle such huge amount of data, the traditional systems that were existing, right, like RDBMS system was not able to handle either the storage or the processing. So in order to handle such huge amount of data, we were in need of a new system. So that is when this Hadoop came in, I believe.
Okay. This is again related to this, Girish, but yes, you added a term, social media. Perfect. Anyone want to add something more?
Yes, it is more on structured as well as unstructured data we can handle over the big data.
Very good. This is what I was looking for. So we have structured and unstructured data. Now, for people who do not know what is structured and unstructured, um, so first of all, let's talk about data so that you get a reference about what is structured and not. So this was, who gave this? I think it's Abhishek, right?
Manju.
Manju. Yeah, I'm. So very good answer. So when we talk about data, right, I think all of you have given the right answer. So I'm just defining it in more detail now. So like somebody said that when I talk about 1980s or 1990s time frame, at that time also we used to have data. But the challenge was that even though the data size was very small, but still we were finding it hard to store it, to process it. We do not know how to deal with that, even at that time. At that moment, companies like Oracle, IBM, these bigger companies came up, and even Microsoft, these companies came up and said that, hey, I give you an RDBMS solution. And if your data have some structure, which can be stored like a tabular format, you can go ahead and use our system. Now, you can not only store the data, but you can also go ahead and process your data as well. And you can develop interesting insight. And today, I need not tell you that these companies became giant, right? Because they hit the market quite well and they were dealing with the data, they became market giant today. Now, what happened with the growing demand? If I talk about, let's say, Facebook, like somebody I think talked about social media. Now coming to the Facebook. Now Facebook, if you look at it, it's just 15 years old, right? Not more than that, 15, 16 years old, not more than this. Now the challenge with them was, in fact, if you look at Facebook activities, what we do, we write some post, we upload some video, we upload sometime pictures, right? We do all this activity, we like or do some activities like that. Now, if you look at this, what's the challenge happened? We started uploading different kind of data, right? Now it's the problem was with Oracle DB or with Microsoft DB, what we had with RDBMS, the data used to be stored in a table format. So when I say table format, it's like a row column, just like how you see in your Excel sheet. So you can define some column names for it. Let's say I say an employee table. Now employee table could have a maybe employee ID and maybe it could have a name within it. Now within that I can say one and maybe name is, let's say, Aditya, right? So now if you look at this, I have a very fixed defined schema and I'm telling it to it that, okay, I have a row and I have a column within it. But if I talk about videos and pictures, now it becomes impossible to store it in RDBMS. I should not call it impossible because you still have the blob and glob columns to store it, but they are not efficient, as well as when it comes to processing, it becomes very next to impossible. So that's where this video and pictures became second kind of data. So this tabular data, we were calling it as structured data. So we were calling this data as structured data. And this video and pictures, which is completely not at all in the pattern, in any pattern, we cannot store in a tabular format, we started calling it as unstructured data. So this is a different kind of data. Now the sad part is that 80% of the data what we have with us today, it's a rough number, it's not like something fixed, but 80% of the data what we have today consists of your unstructured data. And if I talk about structured data, we have roughly 5% of the data only, which we can call it like a structured data, which have the fixed schema and structures around it. Now you may say, what about the remaining some 10-15% where it is lost? Now, this is generally being, there is a third category, which we also use it a lot. In fact, you all might have used it in some of the other projects. This is called as semi-structured data. Let me explain you what is this. So you all must have used emails, right? In your email, if you look at it, it have the fixed defined structure. Like we will be having a from field, we will have a to field, we will have a subject, maybe we will have a CC also, and then we have a complete body, right? It have a fixed structure, but we don't store or keep all this data around in a RDBMS table format. Now, this type of data, if you look at it, we can call it as semi-structured data. Now, if you look at it, even actually, if you talk about Google, how they store it in a key value store. I'm not going into that because once we come to the NoSQL DB, we can talk about it more, that how exactly we store it. But it is not stored in our RDBMS system. So all your emails which comes in goes into some NoSQL DB for the same reason. And this data, though it will have some sort of pattern, but it cannot be stored into DB table. In fact, we more rely on the metadata part of it. For example, you all must have known something called as XML. or JSON format data. Anyone who do not know these formats? I'm assuming everybody knows it. If not, just please feel free to ask. Means don't think that any question is a basic question. Just say that, hey, I want to know about it. So in XML, as you all know, we create tags, right? And within that, we put something, then again, the tag is closed. In the same manner, in JSON, we store the value like a key value pair. Like for example, I would say name is my key, and the name maybe could be, let's say, Lakshmi. Maybe the address, if I talk about, this is a key, and the address, which is, let's say, Bangalore, is going to be my value across for it. So this is a key value pair, which I'm defining it as JSON again. Now, if you look at this data also, we are not storing these data into DB tables formats. We are going to handle in a different way. Like I already took a name of NoSQL DB, but there are a lot many other tools as well. So now this portion is also called as semi-structured data. Again, that's even more right now with us in comparison to your structured data. In fact, if you have developed any microservices or something like that for now, if you do not know what is microservice, please ignore it. That's not a big deal right now. But people who know it, if you have developed microservices and if you have to interact between those microservices, what generally happens is that you kind of transfer the data using some sort of JSON format or some other formats, right? So you make those interaction even using that. So we are having a lot of semi-structured data with us as well. So now this all talks about the data component for it. So we understood right now about structured data. We talked about semi-structured data. We talked about unstructured data. Now coming back to it, this huge part which we just talked about, this denotes the first property of your big data, which we can also term it as volume component of it. In fact, IBM came up with some random names with it, like which start all with V, and later a lot of people added few modes to it. But let's talk about the major component. So when I say volume, now this volume component basically talks about the size of the data. Now, there is a like a lot of people may I would say a lot of people have this conflict. They say that, okay, what at what size I should really call this data as a big data. Now the challenge is even for, if let's say if I'm a startup and if I'm a big company, maybe as a startup, maybe for me 1 terabyte could be a big data. Maybe for a big company, maybe the 10 terabyte could be a big data. So it depends on lot many factors. But if you ask me in a random note, if we look at the current existing hard disk sizes, what we have 16 terabytes as the capacity of the highest size of it. Though yeah, now in cloud they have combined it and you can still create more, but 16 terabyte is like the highest size what we have with respect to storage. Now, so we can say that if we are not able to store or process in a single system, when we fail and we have to go beyond one system, then we start talking with respect to that. We need to work on the distributed system mode, or we can start talking with respect to big data now. So this is a very layman term definition. This is not going to be sort of an official things to talk about. But yes, if you're going beyond some size above 16 terabyte, definitely it cannot be handled by a single system. If basically because the maximum size what we have available is this much right now with us. And even if you're trying to keep on a single system, it may not be that performance efficient as well. So that's something also you need to keep in mind. So this is all the data which we are talking with respect to volume. Now, even I just took an example of Facebook, but in similar way, we have even Twitter. We have so many other companies also like Snapchat, LinkedIn. All these social medias companies are also generating data, which is very huge in size right now with us. And that have actually created the lot of demand with respect to your big data world right now. So coming to this part again, which is the first component is volume. So whenever we define this characteristic in terms of huge part, which we cannot be handled, we are calling it as volume part. Second part is variety. I just talked about different kinds of data what we have. So when I say variety, like we have structured data, unstructured data, semi-structured data, all this kind of data what we have, we can call it as variety component. Now, third component, we can either call it as rate of change or we can say velocity. What does this define? The problem right now in today's world is the nature of the data is very dynamic right now with us. because it may be due to the changes of a lot of transactions what we have. And sometimes what happens is maybe the data schema, what we have used it for writing, maybe I want to process it with a completely different schema as well. So the rate at which this data is also changing is becoming a very important component as well. And that defines my velocity component, means the speed at which the things are changing as well. In other words, we can also call it as well, the rate at which the data is also coming to our systems as well. In fact, I will be showing some case studies around that as well, that how RDBMS system will completely fail when we talk with respect to the higher velocity what we have, and how big data component can help us around with that. So this defines my third property. Fourth property, which is very, very important, is a veracity component. Now, what is this veracity component? Veracity component talks about the quality of data. Now, unfortunately, since all the data which we are getting outside the world, the problem is that this may not be accurate. This may have a lot many issues coming on that, maybe because of different file format, because of the corruption of the data what we have. So how we deal with this also. In fact, we will have some case studies around this as well. In fact, all these components you will be seeing it when I will be going further, that how RDMS systems will fail and why we have to think about only big data systems there. Even the data size could be even little lesser, but still we will be going across with the big data ecosystem. So you should be kind of be able to distinguish where exactly we will be thinking about this big data term. First of all, any questions till this part? Everyone clear? Perfect. Yeah, Kaushik was saying something.
No, we are good.
So talking about one more example now. So we just understood about what is big data with the properties which we have just seen. Now going further, as a second thing, let's take some use cases. Let's understand with some use cases how things works with respect to, let's say, this big data ecosystem. Now, uh, this will be sort of an analogy which I'm going to use right now. So let's say Satish is here, right? So let's say Satish. So Satish, you're a manager right now, or you're a team lead?
Manager.
Manager. Okay. So Satish is a smart manager right now with us already. So let's say Satish have given a problem to one of his smart employee, and let's say he gave it to Abhishek. And Abhishek is the smartest employee, let's say, under Satish. Now, what happened is Satish said, hey, I have 1 terabyte of data with me. And maybe you have a laptop which is having almost 4 input output channels, maybe 100 Mbps bandwidth. And what I want you to do is maybe just write a code for me, which can just count how many total number of words are present in this file. It's a string data, but I just want you to count over it. Maybe I've taken 1 terabyte, you can even increase if you want. Now, if you have to do this on a single system, Abhishek being a smart engineer, he understood that I could use even the multi-cores, maybe he understood multi-threading programming and all that. And he wrote the best possible code for it. And he was able to, once the data processing happened, he was able to complete this whole thing in 45 minutes. Okay. So basically 45 minutes it took him to kind of process this overall complete data. Now, do you think Satish will be happy with this time frame? No, right? 45 minutes seems to be huge. Maybe Satish could come and say that, hey, I understand it's a big data. Maybe it could be 10 terabyte. Maybe I understand it's a big data, but 45 minutes is not reasonable because I have a lot more data other than this also, which I want to run the same code. And if you take this much of time, definitely it's not going to be a good scenario. So I need a better solution about it. Now, Abhishek went ahead, and I already told you that he's a smart engineer. So what he thought was, he came up with a solution and he said, okay, Satish, I can see there are so many laptops which are lying outside and nobody's using them. So I'm not incurring any extra cost right now. So can I use them up? Satish said, okay, go ahead. Now, what Abhishek did, he took 10 laptops. He simply took these 10 laptops And what I did here is he said, hey, let me divide this. Let's say if it was 1 terabyte, let me divide this into maybe 100 GB each, 100 GB here, 100 GB here, and so on. Now, once he have divided it, he was able to now process on all these 10 different machines. And once he finished, everybody can make out, since I'm using 10 different machines with division of data, definitely should be faster. Let's say he took closer to 4.5 minutes to complete this whole operation. Now, I already told you that Satish is okay with anything below 5 minutes. I already told you Satish have no issue with respect to cost. Tell me, what would be Satish's response? Do you think Satish will be happy with this?
Yeah, for this
Yeah, I
4.5
think so.
minutes.
Abhishek and Gauss thinks that he should be happy.
Yeah.
Yes, he must.
He should be happy.
Yes, I think.
The same. Guys, I need others' response also. What do you think, Deepa? Deepa, you can unmute yourself. So I will take random names if you will not speak out, guys. Satish, you have to ensure that we will talk. Yeah. So as everybody said, looks like he should be happy. But to answer you, unfortunately, looks like not. Let me tell you the problems with it. There are a lot many issues. Number one, if you look at this, what Abhishek did here is he took 10 machines and he started working on it. This he did manual division of data, right? First of all, there is a high chance of manual error issue, which he can do it. Maybe he can write a duplicate copy here. Second big problem, think about it. What about if one machine fails? Do you think Abhishek will be giving the right answer? Because if you're using more machines, definitely the issue would be that there could be challenges coming with it now, because machine chances of failure will increase when you're using more machines. Right now it's 10. Assume that he have used 100. Then definitely one machine can fail at any time. But in case if any one of his machine fail, then there will be another problem, right? He will not be able to return the good result out of it. Third thing, if you look at this right now, he did this manual division. Then after that, he started aggregating all this output. All this manual thing he's doing. Don't you think he will end up taking more than 4.5 minutes? Right? So again, this is a big challenge which will follow for him. Now, why I took this example? I have not yet introduced you with Hadoop ecosystem at all, but I want you to leave with a thought process, how we start thinking of Hadoop. How exactly Hadoop thought came in. Definitely, Abhishek have still not given the right answer, but at the same time, he's close to kind of come up with something interesting. If I ignore the second part, which is, let's say a machine fails, let's ignore this part for some time. Can you all feel a need of an ecosystem where I can simply say, hey, I want to send my 1 terabyte of data, I want to save it, and I want to run some code which should be counting the total number of words and aggregate for me. So are you all feeling the need of some software where I just tell him that, okay, take this data, take this code and run it for me and give me the aggregate result. So if there is some software which can help me with this or some framework which can help me to do this, that would be quite relieving for us. And that's where I leave you with the thought process of Hadoop. I have still not introduced Hadoop. There are still a lot of things which we have to talk about, but this is at a very initial level thought that how we can think about Hadoop system, how we can think about distributed system, where exactly this problem falls up. Now, any question on this? I hope this analogy is clear to everyone. Perfect. Now let me introduce you with another example to understand this Hadoop ecosystem in more detail. So let's say two more people join Satish team. So let's say here I have Satish. Let me. Let's say he's Satish. And let's say Abhishek was already reporting to him. Let me take a few more names. Let's say Aditi and Arun. Let's say right now, these three people have joined Satish group and they started working on a project. So what happened is, let's say generally in your teams, you get projects, right? Let's say all these three folks are reporting to Satish and they all are currently free. Now what Satish will do in this case, he will divide the project into three parts, right? He will say P1, P2, P3. He will say, let me go ahead and divide this project and let me give you all this work to start with. So let's say he gave to Abhishek, hey Abhishek, take the project P1. Hey Aditi, take the project P2. Hey Arun, take the project P3, work on a specific timelines and return the result to me and I will return it back to the client. Now in this situation, if you look at this, the challenge is, okay, fine. Looks like everybody can complete it and give it back on their respective time. So in the first scenario, definitely Satish will be very happy if they are able to return everything. But unfortunately, in the corporate world also, we don't always have the happy scenario. Sometimes we could also have some bad scenarios also, unfortunately. So for example, let's say Arun took an emergency leave. Okay, he has some family emergency right now and he became completely unavailable. He cannot basically stick back to the project. Now in this scenario, will Satish be able to deliver this project on time to the client, or he have any kind of thing to be delivered? No, definitely. Now Satish will no more be happy with this scenario. But remember, managers are paid more than engineers. Why? Because they are smarter, right? They always track all these things beforehand. So what he will do, he will come up with a nice plan beforehand itself. So what he will say, hey, Abhishek, um, you're doing a good job. I know you are very responsible. You could be promoted. When you will be promoted, I don't know, but you will be promoted someday. And since you're doing a good job, I want you to back up Aditi project. Now Abhishek may say, hey, I am already busy with project P1. How can I take project P2? Um, the idea is that you are not working on P2 right now, but given if the requirement comes up, if Aditi is not able to deliver, then only you have to work on it. But otherwise, okay, keep working on project P1. Same way to Aditi, work on project P3. And to Arun, can you tell me what should be the project? If you are in Satish place, which project you will give to Arun?
P1.
P1. Very good. So P1 should be coming to Arun. Now in this scenario, if Arun took an emergency leave, who is going to cry? Who have to put extra night outs?
Aditi.
Aditi. So Aditi will be putting a lot of nights out. So definitely she will be like this. Definitely Abhishek will be showing all his teeth. And anyway, Satish will be smiling because he did a good job. He can pat on his back to did a good job. So definitely Aditi have to put night outs. Maybe the project can still get delayed because she have to do extra work. But at least from the Satish point of view, the project will be delivered. And maybe he have taken some extra time for all this. So all these components, if you look at it right now, what is happening around that in this situation, Satish is able to deal with this part and everything works like a happy scenario. Now, one more thing managers do, and Satish can very well relate to it. And if there are any team leads here also, they can also relate to it. Generally, managers, like for example, Satish may have a big team. Now, he cannot remember who is working on what. You don't have all that idea details about it. So what generally managers do is they create a file, and in that file, it could be anything. They could be project management software, or it could be some Excel sheet where he will be keeping all the details. Like he will say, hey, I have a project P, which I have divided into P1, P2, P3. And I have like this project to basically Abhishek. If I talk about Abhishek, Abhishek have the project P1 and P2. Similar way, if I talk about Aditi, she have the project P2 and P3. And if I talk about Arun, he have the project, let's say P3 and P1. Okay. So this is how the current distribution of the projects also looks like. Now, why I took this example? The reason I took this example is because your Hadoop works almost in a similar approach. Okay. I'm not saying that it's exactly going to work, but you can very well relate right now with your Hadoop system also across with it. So what's going to happen with this? Now, definitely, it's no more going to be the basically the humans involved. It's going to be machines now. So number one, if you look at Satish and the employee relationship, can you see this is the master slave architecture, right? It's a master slave. Like Satish is going to command, and Abhishek, Aditi, and Arun have to complete that particular task. So it's a master slave architecture. So the same thing now. Let me draw it here. So let's say this is going to be my 3 parts. Now, first thing is these are all machines. These are no more humans. So, but it follows the master slave architecture. Now, this machine, what you're seeing is like your master machine. And these 3 are my slave machines. Now, what's going to happen? Now, here we were getting projects. But when you're working on the big data projects, you're no more working on the projects. In fact, you are going to get files, directories on which you will be doing some processing. Like in the last example where Abhishek got a 1 terabyte file. So it was a file on which he have to run and tell that what's a word count, total word count of this file. Same way, if you look at this here, so we will be getting a file. So now with this file, there will be some sort of division. So let's say I got a file P and this file is divided into P1, P2, P3. How it's divided, I will come into detail of this, how this is divided. And in fact, how it works internally in detail. Now, so this file got divided into P1, P2, P3. And then what's going to happen? Let's say P1 file will come here, P2 file will come here, P3 file will come here. Now there's some naming convention for it. So this master machine which we have, we can call this machine as name node. Let me correct myself. This is just for your understanding. Actually, this name node will be a Java process, which will be running in your master machine. Okay. So this machine is never called as name node, but just for your easy reference so that you can relate with this particular example, I'm just giving it a name. Okay. But this will be a Java process. Same way, these slave machines, we can call it as data nodes. Again, repeating, this is going to be a Java process running on some machine. So this is going to be data node 1. Let's say this is going to be data node 2. And this is going to be data node 3. Now, one thing which is going to happen in this case is once we have this thing defined, now tell me one thing. Since I'm working on machines, if I go back to this problem of Abhishek, the first problem which I said we have not yet, second problem, sorry. What about if one machine fails? The second problem we have not yet solved. So this problem was, what if a machine fails? Because the chances increases of failure once you have more and more machine attached to it. Now, if you come back here, here also there are chances that one of the machine can fail. So in this case, don't you think the solution which Satish have applied here, we can apply the same solution here also? Everyone agree on this?
Yes.
So here we can have the similar sort of solutions being available. So let's call it as P2 could be saved here, P3 could be saved here, and P1 could be saved here. Now in this situation, if any one of the machine can fail, I'm still okay because the other machine will take care of it. Now similar to Satish, he was keeping the details about like who is working on what. Similar way, even name node keeps all the details with itself. Like it will say, hey, I have a data node 1 which have the P1 comma P2 with it. I have a data node 2 which have, let's say, P2 and P3 with it. And I have a data node 3 which is going to be, let's say, P3 and P1 with it. Okay. So now with this scenario, this file which we are keeping it up, this is going to be very critical file and we call it as metadata. I will be talking about this in very detail in coming few minutes, that what all things we keep inside it, where we store it, where we keep backup copies, and what exactly happens inside Nimrod. All the things we will see. Even we have not yet talked about one more scenario. What about if Satish took an emergency leave, right? We have not talked about that scenario. We will also see that in some time, that how to deal with this situation if the master machine itself fails. Now, but for now, we understood at a very base level how Hadoop works. Now, this thing, what we were doing here, like creating the extra copies, we call it as replication factor. This is called as replication factor. And in this case, my replication factor value is going to be equal to 2. Okay. So in this case, you can see that P1, we have created 2 copies, P2, we created 2 copies, P3, we created 2 copies. So in this example, I have kept replication factor as 3, but let me ask you one question. What will happen if I make this replication factor as 3? What is the change which is going to happen in this diagram?
Every,
Each data node will be having all the three projects running in it.
Correct. So in this case, P1, P2, P3, or in fact, P1, P2, P3 will be available on all the data nodes now across for me. So this is the replication factor part. Now, one thing, this replication factor, they have decided to keep it 3 as a default. Can anybody tell me why? Why they might have kept it as 3? Why not 2? Why not 4? Why not 5? Why not 6? Can anybody think of, means I'm not expecting an exact correct answer, but can anybody think of why they kept it as 3?
Actually, statistically there isn't like a theory where failover look like something happen and something crashes. Like 3 clusters or 3 nodes are sufficient. Like something statistically theory is there. That
Okay, that's close answer, Gauss. Can I get more answer in addition to that what Gauss had just said? So like he said statistically, but I need more detail, like what statistics he's talking about.
Like, see, if one machine or like one project gets failed, like from the other two, they can get the access. But if you have more number of divisions now, so getting the access for each project would be hard. So that is the reason, like they kept a minimum of 3 systems, like division of 3.
Then I can also give it
Shivang, actually the probability of failing,
Hold
the three
on,
clusters.
hold on. You have already given the answer. I need from somebody else now.
If 3 is there, one is failed, or one is working, and another one is backup.
Okay, then that's okay. My another question is, so I understood that 2 is not a good number. Fine. What I'm trying to understand is why not 4 or why not 5?
I think the idea behind this is to keep the cost under minimum. I mean, to
Costing in today's storage wise, I don't know. Actually, hardware is very cheap. Actually, if you go across with the Gauss answer, you will be able to answer it well. So can anybody think about it? And he was very close to answer it. That's the reason I have stopped him, so that let other things also about it.
Yeah, Shivang, at any point of time, one system can go down, and 2 systems going down would be a rare scenario. So that is why 3 would be the ideal number for replication factor.
Okay, that's a good one. Now, let me give you an answer, which actually Gauss was trying to also give. So let's say, this is just an assumption. Let's say there is a chance of one machine failing, or one machine failing is, let's say, 5%. Okay, one machine can fail with 5% probability, which is pretty much okay statistically if we talk about. So that means with 95% probability, it will work fine. That it looks like for one machine, which means if I keep one replica, in that case, the failure comes out to be 0.05, which looks huge, right? And the probability that my data will not be lost is going to be 0.95. This looks good for one replica case. Now, let's talk about another case. If I have 2 replicas. Now, in this case, if I have 2 replicas, don't you think, talking about probability, if I have 2 different events to occur, like one machine can fail and second machine can fail, then what we do generally in that case, we say 0.05 into 0.05. Can everybody recall this from the probability theory? Very simple thing. It's 2 different independent events. So since both the events have to happen, so I will multiply these 2 probabilities. So what will be the output for this? This is going to be 0.0025. Okay, correct me if I have done some mistake here. Now, what about if my data will not be lost in this case? So you can just divide, subtract it from 1. It will give me, I think, 0.99, I think 75, right? So this is going to be the one. In this case, what is the difference coming between these two? If I talk about, the difference is coming out from 0.0475. Everyone is with me on this part? How this is coming, right? Now, let's go to the 3 replica part. Let's go to the 3 replica. Now, in this case, if I have to do with 3 machines failing, I have to multiply one more time with this, right? If I'm correct, if I multiply with this, I should be getting 0.000125. If I subtract it with 1, it should be 0.999. I think 8. There will be some more numbers, I think 875. Now, I just remember it. If I'm wrong, just correct me out again. Similarly, here, if I look at the marginal improvement, it will be not that much, but still it will become somewhere to 0.002, right? From 2 replica to 3 replica. Let's go to 4 replica. Okay. With 4 replica, if you keep on doing this, I think this will come out to be 0.0000625. And here it will be even more reducing, 0.999999375, if I remember it correctly. And if you look at the marginal improvement now, when I say marginal improvement, we are just subtracting these okay, numbers from the above. So in this case, the marginal improvement will come out to be very, very low. Okay, it will be like 0.00001, something like that. It will be very, very less. So from here, if you go from 3 replica to 4 replica or 4 replica to 5 replica, what will happen is this number will start decreasing, which we are talking about the probability that the data will not be lost. Since that number is not decreasing, we definitely don't want to increase the cost unnecessarily just for a very small, means too much decimal sort of changes around it. That's the reason we will be keeping this part to 3, and that's where they basically came up with this number 3 instead of 2 or basically 4 around it. First of all, everyone clear with this part? How we came up with the number 3? So those, that was a good answer. I think you were coming to that when I stopped you. When you said probability, I immediately made out that you are on the right.
Shivan, can you explain why not 4 once again?
So if you go with 4, right? If you do this 2 subtraction, I don't have the exact number, but it will come out to be 0.000, I think 1001, something like that. So the marginal difference is coming to be more lower. Means very small. So that's the reason we are, and even if you will go with 5, it will be even much more lower. So the improvement is not happening that much here. That's the reason we would prefer to go basically with margin 3. But again, all this calculation I have done with an assumption that a machine failure can happen with 5% probability.
Yeah, thanks.
Yeah. Any question from anyone? Okay, perfect.
So, Shivang, is there an acceptable range for the margin of failure? Like, here you say with 5% failure with 1 replica and with making three replications, it would reduce to 0.002, right? So is there an acceptable figure that we need to look for?
So the way we have taken it up is, if you look at this number, means this is basically reducing a lot from here. That's the reason we have stopped it here. Because if I talk about 1 into 10 to the power minus 5 marginal improvement, that's pretty low. But if I talk about maybe 2 into 10 to the power minus 2 or 10 to the power minus 3, it is still a marginal okay difference to go with. That's the reason we have decided to go with this part. And again, since I have done with this 95% calculation, if you are using a commodity hardware. So one more thing in Hadoop is that these data nodes, what we use it a very generic one. Means we don't bother about taking a very high class hardware around it. So even the probability could lower down to 90% also, because you're using maybe old systems which could anytime fail as well. So in those cases, if you will look at these, if you do these calculations again, right, which I have done it here, so you will notice that this difference will be still okay. But after the 3 replica, the margin difference will again go down to a very huge extent. That's where this 3 number came out to be like a magic number coming from this probability theory. In fact, I have worked with petabytes, not in the petabytes, zettabytes of data when I deal with Facebook, and they also use replication factor as 3. So basically at that scale also, they don't go beyond that because they don't see much of the impact coming from it.
Okay, got it.
Yeah. Any other question from anyone on this? Now, one more thing, guys. So this gives me an answer for 3, right? One more thing is, we always try to keep this replication number to odd number. Now, nobody is stopping you to change it from 3 to 5 also. Maybe you think that your data is very critical. Maybe it's a financial data and the client is sitting at your head that, hey, I don't care, but I need 100% confidence that my data should not be lost. Now, I have never come across this situation, but let's say if you come across the situation tomorrow, and maybe you decided that, okay, let me keep the replication factor as 4 instead of 3. That's not a good choice. Okay. Reason being, you should always try to keep your replication factor as an odd number. The reason is, when I will go ahead, I will explain you, we will do something called as checksum. So when the data in the data node, when your data is sitting, a lot of times what happens is your data could get corrupted also, maybe because of any reason. Now, in those cases, it's always a good idea to keep an odd number, because what happens is, let's say I have a block B1. Okay, so let's say if block B1 and block B1 of two machines are of similar checksum, but maybe the third machine block B1 looks like a different one, then in that case, I can easily make out that, okay, it looks like this one is not the right one. And we can easily kind of remove it, and then name node will do some operations to bring back a replica copy of it. But so it's always a good idea to keep it. That's the reason with the odd. So either you're going from 3 to 5, which is okay, but don't make it from 3 to 4. Okay, so that's something, if you have to change it somehow, then keep this number across, because internally otherwise Hadoop will get confused whenever this situation will occur of data corruption. But I can tell you, you will never come across this situation where you have to change it from 3 to some other number. Now, one more thing. Okay, before I go ahead, any other question from anyone on this?
So Shivang, it is basically to identify the the odd one, isn't it?
Identify
The different one. Let's say, for example, 3 to 5 you are telling, right?
Yeah.
B1 and B2 are similar, and third one is a little different. Correct?
Yeah.
Okay. Yeah.
Means, think of it like this. Maybe B1 got corrupted, right? In that case, checksum of these two will come same, but checksum of this will come different, right? So we will get to know that something is wrong here.
Okay.
If you do not know checksum, you can think of it, let's say, doing some hash function, applying some hash function on some data and getting some unique number out of it.
Okay.
One more thing, guys. When we talk about these systems, right? Now, I just talked about this part where we were storing this data. Let me come back to this old diagram. So we were storing this data. Now here, one important thing which comes up, this storage component, what we are using here, we call it as HDFS, which we are going to talk in detail today. Okay? This is called as HDFS, which is, we can also call it as Hadoop distributed file system. Like I said, I will be talking about this in very detail today. Second important component, that should most likely fall tomorrow, but we will still see if the time permits, is going to be a MapReduce or Apache Spark. Now, what is this? So if you look at this here, definitely there should be, when I said that, okay, I want to count the total number of files here, or sorry, total number of words present inside this file. So in that case, I have to definitely send some code, right? Otherwise, how it will work? I need to definitely send some sort of code here in order to do this. So this code, which I'm going to send here, we can either send it using MapReduce or Apache Spark. And we will talk about both of them in detail, that how it works, how they differs, how one is faster, one is slower. We will talk about all of them. But this is the second important component. Third important component of Hadoop is, so let's say if Satish got, let's say, 30 people to report to him, then don't you think it will be very difficult for Satish to do all the job? If I say to Satish to not only keep the records, but also to take care of division of project, monitoring it, taking care of each and every activity, do you think Satish will be able to do it alone? No, right? He needs some help. So for that, we have something called as, in a similar way, we will have something called as YARN. Okay, and we will also talk about YARN architecture in detail. If the time permits, most likely today only. I will explain you how YARN will play a role here and what are the components basically will be involved in it. And in short, we call it as cluster manager. Okay, so for now, don't worry about what it do, because I'm going to go into depth of this, that how it looks like. Now, so these are the three major components what we have today with us in terms of HDFS, which talks about storage, MapReduce or Apache Spark, you can think of it like a processing component, and YARN, which we can call it like a cluster manager, which will help me to manage the whole clusters across with it. Now, then second part, which is again an important component with it. So we just understood about, okay, how this system works, but we have still not talked about how we store the data into my HDFS now. Now, let me tell you one thing. Even this storage, what we are doing here, we are, if we say DFS is something different, it's not. So if you know about your Linux systems or Windows system, operating system, they use some sort of file system within it. For example, you could have either a NAT system, or you might have heard something like a FAT32, right? I mean, if you do not know about them, don't worry about it. It's just that you should be aware of these terms at least, that, okay, these are some systems which are available. HDFS also use the same thing. There is no as such any difference with it. Now let me talk about how basically a file system in Linux or in any operating system stores the data. So that after that we can easily understand what is the difference your Hadoop distributed file system will bring in. So let's say I have a file which is, let's say, of 1 MB. Now in this case, what happens is it divides this file into 4 KB each. Okay, it keeps it like a small blocks. It's, you can think of it like a portions, partitions, what it will create with it, and it will store it. So let's say it will create a file B1 here, it will create a file B2 here, and it will create small partitions and will store in this manner. It basically do it for the random fast reading across, and lot many advantages you have with it. I'm not going much into detail of this because this is again related to your simple FAT32 systems and all that, how they use it. And one more thing what it do is it do not keeps the data in memory basically in the same manner. Let me show you what I mean by that. So if I have to draw your memory, so let's say this is my memory. I'm just going to create some random things here so that you get some insight from it. So in memory, let's say this is my memory location 0, 1, 2, 3, 4, 5, 6, 7. Now, let me tell you here, when I say this memory location 0, 1, actually internally it's not like that. It will be some hexadecimal number, but just for your understanding, I have kept it simple. So maybe it will say that, okay, in memory location basically 0, let me keep B5 file. Okay, maybe in memory location 3, I'm keeping B4 file. In memory location 7, I'm going to keep C7 file. Maybe in 6, I will keep B2 file. In 2, I will keep, let's say, B10 file. I'm just randomly putting some numbers. Okay, maybe C is a different file and B is a different file. But if you notice, we are not keeping in the same sequence. This is how it stores it. This is how internally, though it will be very optimal if we would have stored it in a sequential manner, but there are some reasons why they don't do it like that. If you have done any C programming, especially if you have worked with the pointer logic, then you must be very well aware of it. Now, then if we are doing in this manner, definitely I have to basically in this case also need to have some memory mapping, right? Otherwise, how I will know that where the data is sitting? So for that, there's a memory mapping file within this, what your file system keeps, and it keeps it like this. So I will have a file name. This is going to be file name. I will have a block ID, and I will have a memory location. Okay? I'm just writing it as ML in the short form. So I will keep it like this. File name is B, and the block ID is B5, and maybe the memory location is 0. Okay. Similarly, file name is B, a block ID is B200, and this is going to be 1. So this is the way it will be storing the data. So this is your final storage memory, and this is going to be your metadata, or you can call it like a mapping table within it. So this is how the internal system works. Now, Hadoop also follow the same approach. It do not basically follow any different approach with it. It also take the help of the same file system here. And the way it works is, so first of all, it divides the data into some blocks. Now what happens is, let's say if I have one machine here, let's say I have to draw, let's say, some 8 machines. Okay, 3, 4, 5, 6, 7, 8. Let's say I have total 8 machines here. Now I have a file which is of, let's say, 900 MB. Okay, let's say I just randomly took this number. Now this is 900 MB. So what Hadoop will do, it will divide the data into 128 MB each. First thing. Now this number comes in Hadoop 2.x. I will very soon come to Hadoop 1.x and Hadoop 2.x discussion. So you can think of Hadoop 2.x is the latest working version. Though right now we also have Hadoop 3.x, but we will still be talking about Hadoop 2.x because 3.x is still not that mature. Now in Hadoop 2.x, they came up with this number of 128 MB. Hadoop 1.x, which was the first version, of Hadoop, they used to give 64 MB. If you want to talk about Hadoop 3.x, they made it 256 MB now, but this number is configurable. You can go ahead and change it. But if you're changing it, make sure you should have a proper justification for that. Reason being, if you are creating 128 MB, can you tell me how many files it will create in this case? How many files it will create?
8.
8. Okay. What will be the size of each file? Every file will be 128 MB.
I think 7 will be created each of 128.
Correct. So 7 files will be with respect to 128 MB. So like one file will be 128 MB here, 128 MB here, 128 MB here, 128 here, 128 here, 128 here, 128 here, and the last one will be of 4 MB. Okay. If you compute this, you will get the same thing. So let's say this file will be divided in this manner, and then these will go inside these machines. Think of the same distribution from the example of manager and an employee. Now, when we are storing this 128 MB file, it will again go back to the same way how we were doing it here. So this is the internal storage point of view, how we work with respect to our HDFS. First of all, everyone clear with this? Any question on this point?
Yeah, I have a question, Shivang.
Yeah.
So where will this metadata of the file be stored?
Metadata of this block will be stored with the name node.
Okay.
Okay. So this will be the metadata information which we keep. As you recall from this, this is the local Linux file system or whatever you're using. They internally, like for example, if you save, let's say the current training file, which we are using. So it also will create a mapping internally with the Linux system, right? So the same thing will be used by SDFS also. There will be no difference. So it is leaving to the local operating system to do all this work. But this part will be taken care by the name node.
Got it.
Any other question from anyone on this?
Shivang, last file is 4 MB.
Yeah.
If I need to add another 100 MB, it is continue from 4 MB or it is going to create the new file?
That's a good question. So first of all, in Hadoop, you cannot do any edit operation. What I mean by that, what happens is, let's say when you're working on your laptop and if you have a file, let's say if you open a file, what will happen there is that you can go ahead and edit the file at any location at any point of view, right? But in Hadoop, once the file is written, you cannot go and edit anything within it. It will be only used for reading purpose. That's one of the major drawback, I should say, or in other terms, we can say that it is a difference with the RDBMS system. In RDBMS systems, you can go ahead and update anything as per your wish, but here you cannot do that. In the later version of 2.x, they have allowed to append it. What I mean by that, if you want to add something, so let's say if you have already a file, let's say called as part 000, then you have a file part 001. Let's say all these files are already written as part 008. Let's say in this part 008, you have 4 MB file. Okay. So now if you want to add something as an append operation, then it will go in loop 009. It will not go and do any edit here. Clear on this part?
But a small thing, like if it is going in an extra, but where will it store in the main Hadoop system?
So it is using the same your Linux system or whatever systems you are storing it, right? So let's say if I say this 128 MB, I'm calling it as part 000, right? So this file is getting stored here. Now let's say like Arun have just brought up an example. Let's say I got one more file and I'm using, let's say somehow the append operation. So in that case, maybe it can go to any one of the machines. Maybe that part 009 can go here also, depending on where name node have instructed. We will see that from the yarn side, that how it goes, or when I go to the SDFS write architecture. But so it can go based on that in any of the locations. So maybe in this machine, I will have not only part 009, I will also have part 00, let's say 7. What did Ishwar?
Okay. Like normally you said that only 128 MB only will be stored, right? But again, there will be any partition inside it.
So you can see this one, right? It is already storing it into 4 KB internally for you. It is still going with the fat NTFS and all those file system. So whatever your current existing file system will be there, your Hadoop will use the same thing. It's just that at the bigger file level, it has created into smaller blocks.
Fine.
Any other question from anyone on this? Okay, perfect. Now, let me bring up another interesting thing. So we just understood right now about the HDFS component, that how we keep the data around it. Now, one more thing which I want to talk about, I just introduce you with 3 major ecosystem. One is your HDFS, which is for your storage. Second is going to be your MapReduce or Apache Spark, which is for your processing. And the third one was with respect to your Yarn, which was your cluster. Now, let me quickly walk you through how the whole big data ecosystem looks like. Okay, how different components which we are going to learn in this training, how they're connected with each other. So with this knowledge, once we understand that, then I will go deep into your name node topic, and then we will start talking in SDFS in more detail. Now, to start with, here at the lower level, let's say I have my HDFS setting, which is a Hadoop distributed file system. Now here, let's say I have the Yarn setting, which is my cluster manager. On top of it, I have MapReduce. Here, let's say I have my Apache Spark. Here I have, let's say, Scoop, Flume or Kafka. Let us first talk about this much. This HDFS, as we know, is my storage layer. We want to store the data. So let's say I have some data which is sitting into my RDBMS system. Okay, let's say some SQL data is sitting, and I want to bring it to SDFS or vice versa. Anything could be true. Now, in this case, how I can do this, how I can make this transfer from HDFS to Scoop or vice versa. So first thing is we can use a tool called as Scoop to do that, because we need a connection here, a tool which can help me to connect between both these entities and help me to transfer the data. Second tool, let's say if I have weblogs, like unstructured, semi-structured kind of data. So for those things, I can use tools like Flume, Apache Kafka, and all these tools will help me to transfer the data to SDFS. Okay, so this basically talks about your ETL component, extract, transform, load, right? So basically I'm talking about loading the data to my Hadoop systems. We will be talking about Scoop in detail tomorrow, that how we do that. Now, on top of this, I have Yarn sitting. On top of this, I have MapReduce and Apache Spark sitting. Yarn, I will talk in detail later, but for now, just understand Yarn as the cluster manager. It will help you to manage the things. Now, let's talk about MapReduce and Apache Spark. In Hadoop 1.x, means in the first version of Hadoop, we only had this MapReduce. There was no Apache Spark as a first thing. Now, what happened here was, when I talked about MapReduce, in MapReduce, there were a lot many challenges. Like it was working great, like you were able to work with the big data systems. Everything was going really great. But I will talk in detail why those problems. But right now, let's talk about some problems. Number one, MapReduce was written using Java programming language, and all the code which you can write here could be in only Java programming language. Now, one big challenge will come with it. People who know Java programming also still find it very complex. At least when I learned it first time, I found it very complex, and I keep hearing the same from others. And anybody here who have done any single MapReduce programming, they might be very well aware about the complexity of this part. So Java is little complex. And on top of that, this MapReduce was making it even more complex programming on top of it. So it's not easy to learn. Second thing was, the programming was very specific to some key value pair. Now, what is key value pair? We will see that in some time once I move to MapReduce section. But this key value pair, you are very much restricted to solve it only using this. Third, which was the biggest drawback, was it was very slower. In fact, within few minutes, I will tell you why it was slow. Within few minutes, once I will explain you MapReduce programming, I will give you an insight why this is a slower tool. Okay, why this was, and this was a big headache because it takes a lot of good time, and that's where people do not like it, because if you have a bigger data, it takes even much more time. Now, what happened with this? Though it was working fine with the issues, people start working on something better, and they came up with Apache Spark. Now, Apache Spark solved all these problems for us. First of all, you can write your Spark code in Scala, Python, Java, or R. Okay, any programming language like this. You're not restricted to key value pair. You can write in your own way. We will see to that. Third is it is faster. Why faster? We will see in some time. I will show you with the same analogy way that why this is going to be faster. But this is going to be really fast in comparison to your MapReduce programming. So that becomes an advantage. And now I would say almost 80% of the project right now are sitting into your Apache Spark, but still 20% of the projects are sitting in MapReduce, including companies like Facebook. Okay. Even I work on a project there which is relying on MapReduce. So I will tell you also where this thing happened and which kind of projects still are sticking to the MapReduce component, because 20% is a big number in terms of the projects what we have today. Now, on top of this MapReduce, now we have some more components. Now let's take a scenario where how many of you have watched this movie Social Network? This was the story about Facebook.
I did. That's it.
Okay, how was it?
It was good. It clearly shows highs and lows of Mark Zuckerberg.
Correct. Now, can you tell me how Mark used to do hiring? It was shown in that movie also.
I'm sorry, I did not hear that. Can you repeat?
Do you recall in that movie how it was shown that he was doing hiring, the hiring process?
I'm sorry, it was long back. Sorry, I don't remember.
Okay. Anybody else who can recall that? No one? So everybody only work? Watch that movie. It's an awesome movie actually. So one thing was when Facebook started, I don't know how many of you know it, it was only among universities. It was not made public for everyone. And at that time, if you recall, Orkut was dominating in the market. Orkut was like from Google, and they were like completely dominating in the market. Now, Facebook at that time itself, when they started it off only among universities, even at that time, Mark have kept a very strict criteria to get into Facebook. They used to conduct the sort of hacking competitions. Like you sit across, you have to hack into a server, maybe in a university server, and once you do that, you get the job. So means brilliant people only used to go to Facebooks, even from starting. So now with this, what Mark did when the data was really not that great for them, but it was just among universities, Mark basically at that time hired a team of SQL developers. Okay, because there were like user details and all that, which were all structured, and it was all working fine with respect to it. Now, with these SQL developers, one of the concerns which came up was the data started growing when they moved from university to public model. In fact, it moved so fast exponentially that even Mark might not have predicted it. It went so fast. In fact, some 5 years back, I read a fun fact. You can go and check it also in Mark timeline. It was some 4 or 5 years back. Mark have written that today the number of users who are using Facebook is equal to total number of people living on this earth 100 years ago. It's a huge statement actually. Today, the number of users who are using Facebook is equal to total number of people living in this earth, not one country, in this earth 100 years ago. Now it's 5 years back statement. Now definitely it have increased. So you can imagine the scale what they have gone, and with a very small time frame. So at that moment they realized that the RDBMS systems are not going to work for them. Now the challenge was what to do in this case. One solution was that they reach out to some training center and get their people sort of get trained on it. Not a very good solution, because maybe the SQL developers may not want to get transformed to some programming, because again, if you recall, at that time only MapReduce was there. There was no Spark. So it was only MapReduce, and this is completely Java. So they may not be able to do that well also. And at the same time, they may not be interested in that. They will start going ahead and basically resign and go to some other level because they are smart engineers. Second thing could be that Mark can fire these all SQL developers and hire a new team of MapReduce guys. Again, not a good solution, will bring a very bad name, and they are already good into what they do. So it's not a good solution again. Now, what he did in this case, actual thing what he did was he created a magic box. Okay, he created a magic box. And what he said, okay, SQL developers, write your code in SQL. I will somehow convert this magically into MapReduce and will execute it. So you need not know any MapReduce programming. I will take care of it from basically from my magic box. This magic box, they named it as Apache Hive, and later they made it open source. Okay, so this is what basically they did as a next step, and that is what they came up with on top of MapReduce, Apache Hive. In fact, even today, Apache Hive is very prominent, even after indulgement of Apache Spark. I will tell you why. Okay, it's sometime. Now, the second thing is, so we talked about Apache Hive. Again, you're writing SQL code and everything, but what about people who write scripting language? Now, at that time, Yahoo used to be like Google. Nowadays, they're not. But at that time, Yahoo used to be like Google. They used to contribute a lot to the big data community. So they said, okay, fine. Hive, you can use it for SQL development. But what about scripting people who wrote like shell scripting, Perl scripting, those sort of people? So for them, they came up with something called as pig. Don't ask me why this name. I know it's a weird name, but they came up with this name. And a joke which prevails is like, just like pig can eat anything, similarly, this pig can also eat any kind of data. Structured, unstructured, doesn't matter. It can eat any kind of data. That's the reason this name. But yeah, it's a weird name. I know it. So for scripting people, you can write the code in script. It will convert it to the MapReduce and execute it for you. So you need not bother about this also. Third thing, which became famous was Mahout. This is mainly for your ML things, machine learning. The challenge with Mahout was it was very, very slow. Okay, because anybody here who have worked on machine learning or deep learning things like regression, classification, clustering, anybody who have done that?
Yes, I have.
Okay, so Karthik, you will be aware that in machine learning algorithms, you do a lot of iterations, right? For example, in data, you have the gradient descent. It have to do like a lot of iterative way, so it takes time. MapReduce already is slow. Iteratively, it have to run so many MapReduce program here, and that will make it even more slow. So this Maha on ML again was at that time it was good, but later people have kind of slowly went away with it. Nobody used Mahout, at least what I know of in my client zone. Now, on the other hand, in Apache Spark side, they came up with something called a Spark SQL. Again, think of it just like Hive, but it's going to be faster. Why? Because Spark SQL can convert your Spark SQL written code into the Spark way. And since your Spark is faster, this is also going to be fast. Because keep this in mind, Apache Hive, what it is doing, Hive is you're writing a SQL code, but that SQL is getting converted to MapReduce only. Since MapReduce is slow, even your Apache Hive will be slow because you are also giving some conversion time also here. Though very minimal, but still there will be some time. Similarly for Pig and similarly for Mahout also. But on the other hand, since Spark is faster and the SQL code which you will write in Spark SQL will get converted to Spark way, it is going to be faster. Now, what is Spark way? I have not yet taught you. Okay, this is just at a high level. I'm giving you all these insights. We will come to all this in detail. Now, so this is Spark SQL. Now, why I said Apache Hive is still used? Because now you can also run your Hive query on top of Apache Spark. Means you write the code in Hive, it will not convert to MapReduce, it will run in your Spark query. That's the reason Apache Hive is still prominent in the market. In fact, you will find it more getting used than Spark SQL. In fact, I should say it in a right way that Hive is kind of being embedded inside Spark SQL. You can write your query like that. But Hive is very prominent right now in the market. So you will come across many projects where you may have to work on Apache Hive. Second thing is Spark MLlib. Now this thing completely dominated over Mahout. So Spark MLlib is the machine learning part related to Apache Spark. You can write a machine learning code on top of Apache Spark. It will convert it into the Spark way and run it in the Spark way. That's the reason it's going to be faster. Third thing, which was a game changer, was Spark streaming. Now what happens is, when we talk about MapReduce, you can only work on the data which is the batch processing data. When I say batch processing, you mean you can work on the historical data. Just like you take out your clothes and maybe keep it for 2-3 days, you can keep collecting it and then you wash it all together into a washing machine, right? So that's a batch processing. But what about the case when I'm getting the data in the real time? Think about the velocity component of big data. I'm getting the data into the real time. Means think of a bank credit card. Let's say I'm using my credit card in India right away. And within few minutes, my same credit card is getting used in US, that too physically. It is impossible. Now, in that case, what a bank is supposed to do? Should they block it or should they let the transaction happen and let you know later? Generally, they block it. They don't let it happen, or they will start giving you a phone call to see whether it's a genuine transaction or not, right? Then only they will approve it. So this way, if you look at this process, what just happened here, it's not, means as soon as you entered your card details and it went through a network, immediately in the real time itself, you are getting some resolution for it. Now, this type of thing is done with the help of Spark streaming. Means as and when the data is coming, I want to take some processing to be done and accordingly take some decisions on top of it. So this was not possible to do here, but it was possible to do with the help of Spark streaming. Now within Spark streaming, they came up with structured streaming and all that. Don't worry about it. Once I go to the Spark topic, I will talk a bit on this. Now, one more component, which was, this is not very famous, but still you should be aware of it, called as graphics. Basically, whenever you have some node relationships, for example, Facebook friends, so where you can generate graph, A is a friend of B, B is a friend of C, and so on, right? So you can generate all those graphs. So that you can do it with the help of graphics. Now, this is at a very high level, though I can keep adding much more components to it, but this is at a very high level how your big data ecosystem looks like. Everyone clear with this part? Any questions on it? Or if you want me to repeat on anything, please ask. And this is at a very high level. I have not yet gone to anything in detail.
Shivang, the only good thing I see it on your screen is Mahot, because that seems to be like Indian name, right? For a technology.
Sorry, I did not get it. Can you say again?
Okay, what I was saying was Mahot seems to be like an Indian name, right? For a technology. Mahot.
Yeah, it used to be. I'm not aware about that story as such about Indian name, but yeah,
I guess the origins come from a Hindi or from Hindi, and Mahot is used to the person who rides an elephant.
Yeah, that's a daughter part. Okay, once again, if I'm forgetting that, I think it's called Mahout only, even that machine learning library. 1 second. If I'm forgetting that name, I will just correct it in few minutes. It was a machine learning library written on top of MapReduce. If I recall it correctly, didn't that they call it with this? Let me recall it and get back to you on this part.
No, it's okay. I was just observed and said.
Yeah. Actually, Mahout, I tell you, if you want to know the story, I think the daughter of the person who created this, she have I think a toy called this, which was an elephant, and she have given the name Mahout to it, and that's how they gave the same name to it.
No, I believe the daughter of the creator of Hadoop is the cutting, and he had given his daughter was having a toy, and she was calling it Hadoop, and that's how Hadoop framework got its name.
Correct.
This is what I know.
Yeah. I'm just kind of skipping that story, but I don't recall it. Yeah, but
okay, it's okay.
The same. I know that. Yeah, I think I've just gone into too much of tech into this that I've just forgotten all those old stories. Okay.
Yeah, that happens.
Any questions, guys, on this? Everyone clear, but on this ecosystem? at least now you will be able to relate when I will say, okay, today we will be learning about Scoop, or tomorrow we will be learning about Hive. Now I hope everybody will be able to relate what we are exactly going to learn and how these are linked to each other. Okay, so we will not be talking about pig in this session. We will not be talking about Mahout in this session. We will not be talking about graphics in this session. Spark streaming will be just a beginner level. But rest of the things we were going to go into deep. In fact, there will be a few more components which I have not put down here. That will also be covered.
So one quick question, Shiva.
Yeah.
So you mentioned there will be name nodes and data nodes, right? So all of those will be part of HDFS in this diagram you showed, or
no, so where storing the data node part. So data node is also a Java process. Right? I don't know if you look at it, it's not a machine actually, but where we are storing that data basically keeping portion, the storage component, we call it as HDFS.
So I'm just trying to visualize here. So from this diagram, is it correct if I think of data nodes being in the HDFS part?
That's a part of HDFS.
Okay. Okay.
Any other question from anyone? Perfect. Now let's understand on name node. We will go into detail of name node, how this whole thing looks like. So in name node, what's happening? Let's say this is my name node. This is the RAM of it. And let's say I have a metadata file which is sitting here. Let's say. Okay. Now let's say a client one came, want to access it, this metadata. From the metadata, it will want to access some file which is sitting in this data nodes. Now what will happen if I'm reading this file, first of all, in this situation? Now in this situation, what will happen first from the hard disk, you will bring this metadata to your RAM, and then you will give the result back to the client, and then you will again bring it back to the hard disk, right? Means you will remove it from the RAM. Now, one thing which I want to tell you here, whenever you bring some data from your hard disk to your RAM, we call it as input-output operation. Okay, input-output. And let me tell you, this input-output operation is an expensive operation in terms of performance. It's very expensive operation. So because you have to do a disk seek and all those things, people who are coming from computer science background, they must be well aware of this. In fact, you must have learn it in a course called as computer organization or computer architecture. People who do not know about that or not coming from computer science background, really don't worry, just take it as a fact. If you're reading any data from your hard disk to the RAM, it is always going to be an expensive operation in terms of performance. And even basically in this case, this is called as input output. So now, if in case I did like this, now imagine there are a lot many clients who are hitting, because you're working on a distributed system. Think of something like Google. Google also works on this distributed system. Now, if you're thinking at the scale of Google, what's happening there? In that case, what's happening is you're basically, it's like thousands of, in fact, actually millions of people are coming together within few seconds and sort of hitting their queries. Now imagine they're all hitting to the name node. And every time you're loading this data to metadata to the RAM, do you think it is going to be a good way to go about it? Do you think the performance would be good here?
No.
No.
This is going to be bad. That's the reason name node did not adopt this. Let's go to the other architecture. So the second good approach could be that if this is my RAM, I keep this metadata into the RAM itself. Okay. So anybody hitting in, I'm always sitting into the metadata is in RAM. So it's always going to be faster, right? Looks like a good approach. But do you think it's really a good approach?
No.
Why, Aditi?
Because anything in the RAM can be lost.
Yes.
It's like temporary storage.
Correct. If I restart my system itself, gone. Everything is gone in this case. So looks like a good approach, but it will not work practically with us, because if I lose metadata, I lost everything now. Now what to do in this case? Let's think about something else then. Now, how about I keep a snapshot of this metadata at regular intervals and keep it into my hard disk. Okay, I keep taking the snapshot of this metadata and keep saving into hard disk. This snapshot, we will save it to the hard disk and we will call it as FS image. That's the first thing. Now, we don't take very regular snapshots because otherwise it will also impact your performance as well. Now, if I'm keeping this regular snapshot, am I safe from the last problem?
Yes. So you're keeping a snapshot
yes.
in the hard disk. So even if you restart, the
Correct.
image is still available.
Correct. So this looks good. So FS image, we are storing it, but there is still a problem. Can anyone tell me what's the problem?
RAM is costly. Right?
RAM
All the
is fine, right? Name node can be a little expensive because that's a critical machine.
all the requests will still be hitting the same machine.
Okay, I think you're going to HDFS Federation, which is, I will tell you how that is resolved in some time. But let's assume that it's okay. In the same namespace, if you're hitting this metadata, it's okay.
We can keep that in logs.
In logs, okay. Actually, it's a log file only, kind of. I will also show you once I go to the practical code that where we keep this FS image and the other file. But can you tell me the other problem still with it?
I think Shivam, from we take the snapshots. It has a time interval, right? In that time interval before, I mean, if the system is restarted, the data only have the last snapshot image only.
Correct. Now you were right. So let's say we are taking this snapshot every 24 hours. Let's say this is your FS image 1 and you took the second snapshot as FS image 2. Now, if let's say in 18 hours something goes wrong, don't you think I lost all the data? Right? I still lost a lot of metadata. So what to do about it then? So for handling this, what we do is we take a second approach. What is that? So if you think about with an analogy, let's say Satish being a manager right now, let's say he goes into daily meetings, and in those daily meetings, let's say he create a lot of notes, right? He have a habit of creating notes with himself. Maybe he goes with a diary or something like that, or maybe a file in his laptop. Now, what will happen is if he's creating notes and if he's, let's say, with the company from a good long year's time, then in that case, his file will become huge, right? If you keep on appending in the same file, his file will become huge. Do you think it's a good thing to do that every day he opens the same file and keep on writing in the same file?
No, only is going to take whatever the important in that file.
Correct. Don't you think this will be better that he every day he start with a new file and there he writing it, and maybe once his day is over, he can go ahead and smartly merge it here. Because let's say you have a habit of keeping all the records, all the history also. You don't want to miss it out. Now, don't you think this will be a better approach for him?
Shiva, can you repeat that once?
Sure. So what I said, just taking the example, let's say for Satish, he's a manager. Let's say he's a manager in your company from, let's say, 5 years. Just taking an example. Now, in this case, maybe he have a habit that every meeting he goes, he makes notes. Okay. Now, what happens if he's making notes? His file size within these years will be very huge. Agree?
Yeah.
Now,
yeah.
So let's say every next day when he's going, since this file is so huge now, so do you think next day when he comes, it will be a good idea that he append in the same file? Means he went to the morning meeting, he write it here. He went in the afternoon meeting, he write it here.
No.
And let's say this file you have to open in his laptop and keep writing. Do you think it will be a good idea?
No.
No, right? There are chances he can corrupt something or something goes wrong. So the better idea would be, how about every day he opens a new file? Okay. In the new file, he makes today notes. And once his day is over, by evening, he go ahead and merge it, append it. Can you see this sounds like a better idea? Everyone agree on this part? No.
Yes.
This is the same approach we use here. Kind of. I'm not saying this is exactly the way it works. I will actually correct it once I will go to SDFS writing architecture. But this is just for your easy understanding. I'm taking this example. So now we have something called as edit logs. Okay. So what we do is these edit logs, we keep on appending continuously. Think of it like Satish making notes in every meeting from today back. Now, once he finished this edit logs, he go ahead and merge it here. So like 124 hours is over, he go ahead and merge it. Now, in this case, tell me if in 18 hours something goes wrong, have we lose all the metadata? No, right? We are still saving it into edit logs. So edit logs is the one which will help me to basically save this information for the time gap of the snapshotting. So this way, and every time once it merges it creates a new edit log, again a new file. Again, start writing it. Once again it's done. Again, kind of keep bringing it up and appending it here. Now,
like log rotation.
Yes, very good. Now, one more thing. Don't you think if I keep on doing the same thing here, it's going to be a burdening the name node? Agree?
Yes, yes.
Yes, sort of.
Yes.
Because this is a continuous operation. So for that, we have something called as secondary name node to help us with this. So what we do in secondary name node, this edit logs and your metadata, which is a FS image, get pulled up. And what happens, this basically this combination works happens here. Once it is done, it just replace it with the updated one. Okay, so there's a secondary name node, which is now also having some sort of metadata with us. Now, one thing is this secondary name node, which I talked about, cannot act like a backup. Keep it this in mind, because here we are only basically this. You can think of this as an analogy, like if you have a hard disk, okay, in your own laptop, this is fine. But have you all must have used the external hard disk, right? In your external hard disk, what you do, you keep creating the backup. Maybe you're doing some operation in it, and from that external hard disk, you're again bringing the data to your inbuilt hard disk. Now, in this case, can external hard disk act like a main laptop if my laptop is down?
No.
No, right?
No.
Something similar to what secondary name node is doing. Though on secondary name node, you are still working with your edit logs and FS image, sort of making an image better. But at the same time, we want to ensure that, okay, this is not the backup. So keep this in mind. So this was one of the failure point in Hadoop 1.x, because in Hadoop 1.x, we had only one this thing. Okay, so but in Hadoop 2.x things have changed. I will tell you about that. I will also talk about something like a block reporting and all that, which your data nodes do, and then it will become clear that how exactly another name node will help you in also acting like a basically backup in case if the main name node fails, second name node will immediately take care of it. We will see to that in some time. But for now, just understand from the name node point of view that what all activities happens. So in FS image, what all we keep the file to block mapping, because that's what we keep in the metadata, right? We are also going to keep the block to data node mapping, like in which data node I have, when I say file to block, think of it like I have a file F, which is divided into F1, F2, F3, like that. Block to data node mapping, this F1 file is sitting in this, and so on. Directory hierarchy also, like how my directory sort of looks like, how my structure sort of looks like. So it basically, if you talk about it, it contains mainly your complete state of your system at any point of time, if we talk about it. And if I talk about edit log, this is going to contain all the changes, or you can say updates to the file system with respect to the latest FS image. So that is what it will do. So if your memory went down and if your name node starts, then your existing FS image and the edit log on the disk are going to be combined into a new FS image and again loading back to the memory. And again, your edit log will get refreshed. Any question on this? I hope everybody got the idea on the architecture of name node.
I have a question, Shivang. So in the secondary node, right? Will there be a RAM with the metadata there as well?
Since we are doing some processing, yes, there could be, because otherwise how you will be merging this operation? For doing any processing, you need RAM.
Yeah. So will it be like all the edited logs, whichever one image is formed, will go to that RAM and from there come to the primary node?
Yes. So first it will be like edit log and FS image will be taken up here, because we also have the snapshot being copied, and then basically edit log will go here, we'll update it, and the updated copy will come here.
Got it.
It's still helping me at least to store the metadata. In case if let's say I lose this machine completely, I lose the hard disk, at least I have a backup. Think of it like, again, external hard disk. External hard disk can act like a backup for me. At least if I get a new laptop, I can again bring back all the data. That's the same thing here.
Okay. But what if our secondary node goes down?
If both goes down, then God can save you. All data is gone.
Okay. Okay.
Yeah, but we have ways to handle it. I will also talk about that. But in the current learning which we have done, God cannot save you in this case, unfortunately. So you're gone with the data. Now, everyone clear on this part, how this whole things are working till now?
So, Shiva, so what you said now, is that just for write operations and both write and read operations?
I have not yet actually talked about anything about write and read. That's the next step actually I'm going to come in.
Okay.
I have only talked about right now with respect to how your basically name node sort of works. So don't assume right now, because I have not yet introduced anything in data node side.
Right. Yeah.
So this is just a very high level overview or architecture only for the name node.
Okay.
Secondary name node is in community or which contains community hardware or
sorry, Manju, your audio was not very clear. Can you say again?
yeah, a secondary name node which it contains community hardware or any high costly hardware which it contains like RAM and all.
It will definitely not be a kind of a costly hardware. It could be any commodity hardware as well. Generally, the name node should be very good, so that should be costly.
Okay.
Now, one more thing, what generally happens, like since you guys have asked this question already, so what we also do is a lot of times we keep multiple name nodes. So what we do is we say that, hey, all the metadata related to sales, keep it in this machine. All the data related to marketing, keep it in another machine. All the metadata related to IT, keep it in the other machine. Think of it like a namespace. Because what will happen if your data is growing within the same name node? Think of it name node like a directory now, right? In the same directory, if you're keeping all the files, it will be hard for you to search also. So what we can also do is we can separate it out with respect to namespaces. Like sales may be completely different machine where I'm keeping the data. So this adds up to little more higher availability because these are all independent also, and this makes the searching process very fast. So this we call it as HDFS federation. Okay, so this is also used actually when you will be working in your productions. You will definitely be finding this out. Okay, any question till here? In fact, let me stop here. And since we have covered a lot of things for now, let me open the forum for question answers. Guys, any question? Feel free to just shoot. Don't hesitate in asking any question, guys. I know we have just talked in last 2 hours on these aspects, but these are very important because once I will move to the optimizations components, then knowledge of this is going to be critical. No question?
So I have a question. I don't know if we are to that point yet. So am I correct in understanding that all the requests that come to my Hadoop system should go through name node?
Not mandatory. I will correct you in some time. So okay. Yes, it's going to come in the second half.
Okay.
So basically, you are talking more on the HDFS reading component, right? Of HDFS reading.
Not necessarily. Yeah, I guess, but that's okay. We can. I think I'm going ahead. I can wait.
If you want a quick answer, I can tell you that this happens to the SDFS client. Definitely, SDFS client also needs some permissions, which name node will give, but SDFS client will be directly going and reading the data.
On top of that, I have another question. Will there be multiple name nodes and there'll be one thing which will, route to different name nodes?
If we are talking about SDFS federation, yes. So these are 3 different machines which are basically available here. So in fact, let me ask one question. How many of you are already working on big data right now? Anyone who have at least started with some projects?
But I think most of them are working on big data.
Okay. So most of you are already aware of all these things which we have discussed?
No, this in depth, I'm not sure.
Okay.
And Shiva, I have a question. Like initially when we set up this Hadoop cluster, right, with some n number of nodes, and we would set up this replication factor as 3. And later, if I have a requirement of increasing my cluster size, and then if suppose I change the replication factor, how would that replicated data would adjust with the new configuration?
Okay, I will be talking about that when I go into SDFS. There is something called as disk balancer. So I will be talking about that, how exactly in those cases the name node will be instructing and how exactly it will be passing. In the second half itself, this will answer your question.
Okay.
And coming back to the question about replication, so when we say replication, are we talking about replicating just the data nodes, or are we, you said there will be only one main node, name node. So what does it refer to in actuality? Are we just talking about data nodes or everything?
No, we are talking about everything. Yes, I have not yet introduced at the name node level. So right now what we have discussed is at the data node level, how we save the data by using replication. We just introduced a new term called as secondary name node very quickly right now to understand that how this do and how it at least keeps the backup of metadata. In the second half, I will introduce you with something called as, basically this is your main, this is one copy and there will be another copy. Okay, we will be calling it as passive copy of this. So what this will do, how this is going to be introduced with this, and in fact what will happen is all these data nodes will also report to him. But I will be talking about this in the second half, because to understand this you need to understand SDFS read and write architecture.
Right. So living about the new component, just when we say like replication factor of 3 that we talked till now, what does that refer to? Just the data nodes?
Yes, that is only applicable for the data node, not for the name node.
Got it.
Okay.
Like you mentioned, there are 20% of companies still using MapReduce. Like, and what processes they are using, like still, and why they are still continuing with that instead of like available of Apache Spark and some other processes.
Yeah, allow me time till the last hour of this, because once I will introduce you what is MapReduce, why it is slower, and when I quickly introduce you with Apache Spark, how this makes a difference, then you will automatically get the answer.
Okay.
And again, I will use the same analogy process so that you understand both these things and able to relate why this happens.
Yeah, that's fine.
Yeah, any other question before we go on a break?
What is the maximum replication we can give? 3 is the default. What is the max we can give for the application?
You can go ahead in your configuration file and do it, but definitely keep it equal to the size of your cluster, means size of your data nodes. Because increasing more than that, do you think it makes sense?
Mm-hmm.
No, right? Let's say if I have 3 data nodes and I'm saying that my replication factor is 4. It's of no use.
Okay. If we are using like 10 nodes, then what is the replication we can give?
Yeah, then you can do.
Okay.
So it definitely, you should be restricted by the size of your cluster. So what is the size of your cluster you guys are using in your own company? Anyone aware of it? Especially I think senior folks should be aware of it.
Well, Shivang, that depends on the client these guys are working. So the people working for different clients, right? So it again depends on what client they're working.
Okay, okay. So, but it will be in the scale of thousands or something, right, Satish?
Yeah.
Okay, then I can probably bring some examples around that. That's the reason I asked this question.
Sure.
Okay, any other question, guys?
Yeah, Shiva. So are we covering this MapReduce part today itself?
I hope so. I will
Okay.
try my level best. Otherwise, it will spill to tomorrow morning. Oh, sorry.
Okay. Okay. No issue. So since you said you have written some book on Cloudera, are you familiar with this guy called Arun C. Murthy?
Aware of who?
Arun C. Murthy. So he is the current CPO of Cloudera.
No, I'm not aware. Basically,
Okay.
CTO and CTO level people don't interact with us.
No, no. The reason I asked is since you will be covering this MapReduce part. So this guy Arun C. Murthy. So he was the guy who was leading this MapReduce team at Yahoo back in 2000s, and he was leading the team both from offshore and on-site. So that was one kind of motivation for me back why I started to learn this technology.
Okay.
So there is this Indian connection with Hadoop. Many people would refer to Doug Hadoop. So he is the father of Hadoop, but even we have this Indian origin.
Okay, that's good to know.
Yeah, and he's from Mysore.
Yeah. In fact, the more better part is that you got motivated by some Indian on this. That's immense support.
Yeah.
Yeah, I will show you the snapshot of that book. It's basically more of a kind of a Hadoop and Spark, but majorly on the Apache Spark side.
Okay.
Okay, then I think we can go for a break. Guys, be back on time. So let's start exactly at 2. Okay, so don't be late. We will quickly review on the things we have done in 2 minutes, and then we will move forward to the next topics.
Yeah. Okay.
Thank you.
Thanks.
Thanks, Shiva.
Hey, hi everyone. I hope everyone is back. I can see very less people right now. Okay, guys, can you quickly inform your teammates to join back so that we can start? I can see 10 people missing right now.
Sure, Shivank.
Okay, guys, still the number of people are very less. If you can ping your friends or if you have any internal group, if you can communicate that the class is going to start in a minute.
Hey, sure.
Yeah, thanks.
Shivank. Yeah.
Okay, so let's start. We still have 5 people short, but let's start. So we started with Hadoop systems. We understood the requirement why we need it with understanding of big data. And then we understood a lot of components within it. For example, we understood about name node, we understood about data nodes, and we also understood within name node how things works. We also looked at the Hadoop big data ecosystem, where we also understood all the components which going to be important to understand from the big data perspective, like MapReduce, Apache Spark. On top of MapReduce, we do have like Apache Hive, Pig, Mahout, and then on the other side, we have Spark SQL, Spark Streaming, Spark MLA, Spark Graphics, and so on. We also saw how we can transfer the data from RDBMS to SDFS or vice versa, which we can do it by using Scoop component. And then if you have unstructured or the semi-structured data, you can use Flume or Apache Kafka for it. Now, just before this part, we understood name node in detail, where we also discussed about what is an FS image and what is an edit log. So these things is what we have discussed. So if you look at name node responsibility, it is mainly helping you to regulate the client access to the file, number one. Number two, it will help you to manage the file system namespace, because we just discussed with HDFS Federation that how this namespace play a role here. And it also help you to execute the file system operation, which could be, let's say you want to name some file or rename some file, you want to close it, you want to open it, all those things you can do it, right? Name node also takes care of your replication factor for all your blocks. So name node is also going to receive regular heartbeat. I will talk about that. So heartbeat is something like I'm just telling that I'm alive. And it also receives all the block report from all the data nodes. So now, if you recall, in the data nodes, we were keeping all the blocks. So it will also be keeping all the block reports from all the data nodes. and it will ensure that everything is alive in terms of data nodes, and it will take care of all the replication. If they're under replicated or over replicated, it will take care of that. On the other hand, if I have to summarize the data node component, then they are mainly used to kind of keep the data part itself. They are also responsible to send the heartbeat. So when I say heartbeat, I just explain you that you're just sending a signal telling it that yes, I'm there. And that's how only name node gets to know that this data node is alive. And based on that, it sends some instructions that, okay, go ahead and do this for me. Um, so what we are doing basically here, we are creating, we are maybe replicating, we even are deleting, but we cannot do any update process. Keep that in mind. We cannot keep any update process. We can append, but we cannot do any update process into an existing data block. And this will be mainly from coming from the instructions from the name nodes part. Now, they are generally provided a very large amount of data, and that's the reason we are keeping it into the distributed mode. Now, we also discussed about FS image and edit log in detail. So I'm not going into that again now. So we have already discussed all those things in detail. Secondly, when we discussed about secondary name node, which we saw that it will just be kind of going to be like a helper. It will not act like a backup, but it will be just a helper for the name node. And it is going to regularly get your edit log from the from basically the main name node and apply them to the FS image. And once your FS image gets updated, you are going to return it back to the same client. So sometimes we also call this secondary node also as checkpoint. So sometimes you will read this reference as checkpoint node as well. So don't get confused if somebody say checkpointing. It's exactly the same. Now, if I have to summarize all this which I have just said, and if I have to summarize it in the form of maybe a diagram, so the way it will work is, so let's say this is my client. I'm denoting it by C. Maybe here I have a name node process. Maybe here I have a secondary name node process, SNN. Here, maybe I will be keeping, let's say, the metadata, all the metadata which I have, right? It will be keeping, name node will be keeping metadata. And what all we are doing here. So first of all, from the client, what operations we can do here, we can perform, let's say, the metadata operations, right? So all the metadata operation we will be doing here, because name node don't keep the actual data. You can also be sending that direct read write with the help of SDFS client. I will talk about that on your data nodes. So let's say these are your data nodes. They could be multiple. Let's say I can draw even more. So they could be multiple data nodes, which basically will be part of, or you can call it like a cluster. Now from your name node, you can have like some operations instructions also given here. But we can call it like, let's say, block operations. So we have already discussed all these things in detail. So at a very high level, if you look at it, this is how the architecture of SDFS looks like, right? So, and again, this is nothing new. It's the same thing which we have just discussed. Now, one more thing which I am going to bring up now is called as standby name node. Standby name node. Now, what is this? This is mainly provided in your Hadoop version 2. And the main thing was to keep the high availability feature in mind. Just like when we discussed our secondary name node, it was not providing any high availability for you. And if your name node is down, your system, your whole cluster will be down. So it is going to be like a backup for your main name node, and it will immediately take up all your duties, which once your main name node is going to fail. In fact, all the information in your standby name node will be in synchronization with the name node itself, because once your data node will be sending the block reports and everything, what's going to happen is even the standby name node will also have access. So if you recall, I draw this diagram before we left off, where I was explaining that this will also be connected with the data node. Though only one will be active, like this will be, let's say, active. This will just sit in the standby portion, but it will have everything what is available here also. So it's listening to everything. So think of it like a hacker who is just listening to all your conversations and keeping everything with itself, but not taking any actions on it. So that's going to be a part of this thing. Now, we also talked about SDFS federation. So there is something I've gone into it. Now let's talk about read architecture. So what is going to be the reading way when we comes to HDFS? So the idea would be, I will be talking about some HDFS components like read architecture, write architecture. Then I have still few more things to talk about. But further to that, I would, if the time will permit, which mostly will be, I will be taking you to some HDFS labs, so that at least you get some hands-on from today's session itself. Tomorrow class is going to be more hands-on heavy, because today's session was more on the architecture aspects and all that. So tomorrow it's going to be more hands-on heavy, because we will be going into scoop and all these things in detail. Okay. Now, so starting with this, so what all operation happens basically here? So let's say you are a client, or you can think of yourself as a user application, client or a user application. Now, what all you will do? So there will be an HDFS client here, HDFS client. You will have your name node sitting here. Now, what all things gonna happen? Let's say the client will send an open request. Okay, it will say that, hey, I want to read all these files. Now, what it will do is, it will immediately open a RPC request. So this is going to be an RPC call, remote procedure call, and it will say, hey, go ahead and tell me about this particular file. Now, at the name node level, all the checking will happen, whether the file is the valid file, it exists or not, whether it have the appropriate permission or not. Once it gets that, it will return the list of data nodes. Now here, when I say list of data nodes, it will also send it with respect to the proximity of the client. What I mean by that. So basically for client, all the data nodes could be present at different locations. It's not like that everything will be at one location. Just think of an application, let's say like Aadhaar card. Okay. Now in Aadhaar card, you have seen that what happens is when you go and to any website, these days you give your Aadhaar card number, and basically they will go ahead and validate for you whether you are given the right information, you belong to the right person or not. Now we have like such a huge amount of population with us, right? We in India, we have such a huge amount of population, and we have so many Aadhaar card information across. Now in the whole India, the data nodes are sitting at different states, and in one state we could have multiple data centers as well, where the data is being kept up. So now what happens is, based on once you receive a request, let's say you want to validate it on some website, that this is my that we call it basically that we want to validate it, right? So once we want to we call it as KYC, sorry, we call it as KYC a lot of times. So when we basically want to validate it, what happens is, when you send this request, it will send you not just any data center, because otherwise there will be a latency with respect to network time also. So what it do is, it ensures that where the nearest location of your data is present, based on that, it starts sending you in the same order. So that's what we are basically doing here as well. Okay. Otherwise, it will end up taking more time to validate, and that will be a very bad design. So now, once it receives it, what's going to happen? It will receive, let's say, a list. And once it gets that, then let's say I have some data node sitting here. It will be asking it to send the data. So it will say that, hey, give me the request to read the block B2, let's say. It will send this request. And what it will do is, it will also store it. Let's say for B1 block, it's being present, let's say in, let's say data node 2 and data node 3, like that. So let's say it's data node 3. So it's telling that, okay, in data node 3, go ahead and read that. And maybe after that, the list is data node 1. So data node 3 is nearby, data node 1 is after that. So if in data node 3 it fails, then only go and try to read B1 in data node 1. So this is what it means here. So it kind of keeps it in a table format. So this will be in a tabular format, how we will be keeping the data. Now, once it sends this request to read read B1, then what will happen? It will send the data packets to it. It will start streaming the data packets and will return the copy of this to the user as well. So this is how we will be performing all this. So what all steps we have done in this? So first step, user is providing a file name which he wants to read to the HDFS client. Then HDFS client sends an RPC request to the name node for reading that particular file. Then we did all the validation at the name node level. From name node, it retrieved the list of the data nodes for the first few blocks, let's say B1, B2, and so on, for that particular file which you want to read, and sort that list according to the nearer part for the client, okay, which is more near. Let's say data node 3 is more near, so it will send it first, then data node 1. So it will send like a list in the same order. Now for each block, that HDFS client basically is going to use some socket connection, because it have to connect to the data node, right? So it will use some socket connection to connect to the data node, which is, let's say, at the first part of the list. And once it does that, it's basically going to ask for the block ID, offset, and basically the length of the data which it wants to read. It will have all the information coming from the name node. And once it gets that, it will stream the data back to the SDFS client. So this is what the step will happen. Because it had first requested, then it will start streaming the data back to the SDFS client. And to the SDFS client itself, it will start buffering it. Once these data packets are going to be received by SDFS, it also do one more step, which I forgot it. It also kind of verify a checksum. This is also important thing to kind of look at. So it also verify the checksum. And if there is any mismatch, it will immediately inform the name node that something is wrong, and then immediately go and start looking at the next data node in the list. Okay, so it will start reading the packet again in the same process. Now, this is what all the steps will happen. And similarly, the remaining blocks will also start after that. So let's say B1 is read, then after that for the B2, the same process will start. It reads the data in a sequential manner. Okay, so this is how we will be performing the read operation. Everyone clear on this part, how the read operation is happening?
Could you explain a little bit about the checksum process?
So basically, checksum, what happens is for every block when you save it, right? It also have it keeps a checksum in the metadata information that okay, this block we are storing, and this is basically the checksum for it. Now, what happens is when you're reading it back, when you start reading the data back, what if in the data node something went wrong? Maybe some corruption happened in the file. So what we want to ensure is that from the data node when we're reading it, so we are reading the correct file. It should not be a corrupted file or something.
And so this checksum data will be there in the metadata that the name node sends itself, is it?
It keeps that information copy.
Okay.
Yeah. Any other question from anyone? And in fact, guys, checksum is a very important operation. That's the reason I said I just forgot to say that, but this is a very important operation. Without that, it will not let you go ahead. Okay, now let's see how we perform the write operation. This is little tricky, so I need your complete attention on this, because this is little complicated in comparison to read operation, but it's very simple. Let's say again you have a user application. So first I will tell you with a proper diagram, and then I will tell you all the steps again, just like how I did in the read operation, so that you have a complete picture of every step by step what we do. HDFS client, name node. This is a client or user application, whatever you want to call it. Let's play with this. Then I will create HDFS also later. Now, in this case, what all gonna happen? First thing, you're gonna send the file. You're gonna say, hey, I need this file to be written to my client. Now, what's gonna happen? This HDFS basically client, what it will do, it will inform to the basically name node that, hey, I want to basically write something to you. Now what it's gonna do, the name node will not say, hey, this is the data node list, go ahead and start working. No, it will not happen like that. So initially what will happen, it will give you a lease. Think of it like a permission, like a chmod permission, right? Hey, you can go ahead and write it. Now the client will get back this lease. Okay, so it will get this lease. Now once it is done, now the client will start buffering the data to my HDFS client. And it will keep buffering till the time the block size is achieved. So let's say the block size is 128 MB. So it will keep on buffering till the time that block size is achieved. Now it will keep this data into something called as data queue. Okay, it will keep this data into data queue. Now, once it is doing this part, as a next step, what it will do, once it have to, because even the other blocks will be also coming. That's the reason this queue is important. Now, once it is done, so what will happen, before it starts sending the data, it will be also basically saying that, hey, I am requesting you to now add the block, because now I got the data and I want to now write it. So it's basically now going to request to add a block. Once it get this, then after that, it will give the list of data nodes. Hey, go ahead and write in this. It will give you these data nodes lists. Once this data node list is achieved, then from the data queue, it will be sending this data to acknowledgement queue. So there's another queue where it will be sending the data, so that basically we want to ensure that if the replication factor is 3, whether we have written down to all the blocks, all the data nodes or not. That's basically the intention here. Now what's going to happen, once it get the list of it, now to the data nodes, let's say these are my data nodes, what I have. Now what it will do, it will say, hey, go ahead and write all these packets here. So it will say that, hey, go ahead and write the data packets for me. And these are the data packets, what it's sending. Now, once it is done, now remember, if let's say it got the list like this, it said that, hey, I need data node 1, data node 2, and data node 3. Okay, 1 second. How come it became, okay, so data node 3, and this is a data node 4, but let's say I want to only use, I got the list as data node 1, data node 2, and data node 3. Once it have got that, then what's going to happen, it is now this data node 1 first it will write to itself. Then after that, this data node 1 will say that, hey, go and write this packet to data node 2. Same way, data node 2 will tell to data node 3, go ahead and write this data packet. So this data packet is getting passed from here. So it's not like it will be writing all these packets in parallel mode like that. So it will be writing it in this manner, in a sequential manner. Now, once it is done, everyone will be also sending back the acknowledgement. So it will all be sending the acknowledgement that yes, it's all written here. And once the acknowledgements for everyone is received, it will inform the name node that yes, I have written down basically the file. The write is complete for me. You can go ahead and commit in your metadata log. This is the happy scenario when nothing fails. If something fails down, then again, what it will do is it will immediately, since it will not receive the acknowledgement. So first thing what it will do, it will push the data back to the data queue from acknowledgement queue, because definitely the data is not written. And then again, all that step will be performed with the further list of this. So maybe then after that, you can remove this. Sorry. So this, so earlier it had created a pipeline from here, right? So now instead of this, it will be creating a pipeline from this one. Maybe this is getting added. Maybe this is completely removed. Okay. So these are the steps, what it will perform in the writing. So let me again repeat all the steps one by one. And then again, I will open the forum for question. So what all you did here, your client or the user application, give the file name as your input to your SDFS client. The SDFS client is going to send an RPC call, because here also you need to connect with the name node, right? And to the name node to tell that, okay, hey, I want to create this file. The name node, after creating basically that, it will also check whether you have permissions and not. And then it will grant a lease for you. It will say that, hey, you can go ahead and write it, sort of a permission to you. Now, after that, user application is going to start writing the data for you. And the HDFS client is going to start buffering the data until it is going to reach the size of the block. Once the block size is reached, for adding the block, the HDFS client send another RPC request to the name node. Okay, you are going to tell that, hey, I want to now start adding the data, which is going to happen here. Now, name node is going to return the list of the data nodes where you can write your particular block. The basically, generally the list is equal to the total number of replication factor, right? That's pretty obvious. Now, you will create a pipeline after that. Now what you're going to do, the HDFS client is going to split your data block into small packets, because you're doing the transfer over the network here, and it's going to put it into the data queue. Now HDFS client is going to start writing these data packets to the first data nodes. So let's say if it was data node 1, then it will start writing it up. The first data node is going to store the data locally, because it's going to be in this present system, and it's going to propagate these data, the same data packet, to the second data node. Similarly, the second data node also going to store the data packet locally first, and then passes the data to the third data node. Now, once the first data node receives the packet, it is going to also acknowledge it back, the same to the HDFS client itself. And similarly, other data nodes also acknowledge it through the pipeline in the reverse order. So it will keep telling that. So it have to receive basically 3 acknowledgements back. So one from data node 1, then data node 2 will return it back to data node 1, then data node 1 will again tell it back to HDFS client that, hey, I've got for this one as well. Now, in this pipeline, the data nodes can keep on continuing to accept the new packets as well. It's not like once it is one packet is getting written, so you cannot write any other packet. You can still keep on doing it and keep on sending those acknowledgement back as well. Now, what is the next step? SDFS client is going to write the packet, and the packet is going to be moved. This step I forgot to again mention. So basically here that we are going to move all this packet to the acknowledgement queue before we are sending this, because here we have to, it's important that all the acknowledgement is also got. If it will not receive all the 3 acknowledgement, then in that case, it will inform the name node. And once it is done, it will push the acknowledgement queue back to the data queue, telling that, hey, I'm not complete, I'm under replicated. I've still not gone that. And then once it will again got a list from the name node that, hey, go ahead and write it in data node 4. You have already got 2 acknowledgement from 2 machines. So that is fine. But the third machine take this, create a new pipeline and push the data to data node 4. And in this way, your complete data will be written. And once it is written, it will inform the name node, I'm done. And with that, name node will go ahead and update its metadata. Any question on this part? That's the reason I'm going very slowly on this part, because I know this is a little tricky, but at the same time, it's very simple also. Any question on this part?
No.
No, sure.
Sure. Then we are good to understand basically the reading and the writing component of SDFS. These things are actually important for you to understand because generally, whenever any new system comes up and there's an argument that, hey, why this is better than this, you should really understand that why we are talking about all this part as well. Like even now, instead of SDFS, there are so many storage components running around. And a lot of times we have this argument that, okay, if we are doing this SDFS way, this happened. So I think this should be faster. This should be slower. All those arguments, basically, you can do it with it like an architect. Okay. Now, we just understood now the HDFS portion. Now, there's one very important portion called as rack awareness. What is rack awareness? It's a very simple concept, very, very simple concept. The idea is it just want to ensure that we do not lose the data, even if my entire rack fails. What do you mean by rack? Now think of a rack within which I could have multiple data nodes. I could have multiple places, multiple machines where I can keep my data. So I want to ensure that I am not keeping, in fact, I should say no more than one replica is going to be stored on one node, first thing, because in one system, I would not like to keep 2 copies of the same file. And one more important thing to keep in mind, that no more than 2 replicas are placed in the same rack. So if my replication factor is, let's say 3, so let's say if this is one rack, this is another rack, maybe I have another rack. Okay, let's call it as rack 1, then rack 2 and rack 3. Now in this case, let's say if I have one machine here, I'm keeping, let's say A here, and maybe then I can keep A here or A here or A here, but I should not do that in rack number 2 itself. I'm keeping another copy of A here. This is wrong. Okay, so I should not be keeping 2 copies of the same file if my replication factor is 3, more than 2 copies of the same file in the same rack. So think of a rack as a kind of a cluster with multiple data nodes across. So that is basically what you will be taking in the rack awareness, because sometimes it do happen that the whole rack is down because of some switch problem, could be anything. So that's something we would like to ensure on this. Clear everyone on this part also? This is a very simple concept. Any question, please do ask. Okay.
Yeah, sure. Like in this previous slide, like you have mentioned AA in the same rack, right?
Yeah.
Already A is there, again why A in the same rack?
So first of all, when I say rack, right? Rack, think of it like this. Let's say this is my rack. Now this is one data node, this is another data node, this is another data node, this is another data node. Okay. So in one rack, I have multiple data nodes here. Think of it like this. So in one machine, I have this. In second machine, I have this. Okay. So it's not on the same machine. It's on different machines, but in the same rack. So what rack awareness is telling me, in a single rack, I should not keep more than 2 copies of it, of the same. Okay, so I should not be doing like I save in another data node also here. Got it? So these are machines within the.
Okay. Yeah.
Have you seen your storage rooms in your office? Like, have you seen there's an office just like in a library? You will have like a lot of computers sitting into one sort of, just like in a library, right? If in one rack, and then there will be this is a walking path, and then again here also there will be a lot of racks, a lot of systems will be kept, and outside the door it will be written no entry. Have you seen?
Server room?
Yeah, server room. Have you seen that? At least from outside?
Yeah. We have seen.
So this is basically one rack where you have multiple machines like together sitting. So they will be like connected with a network with a wire together.
Okay.
Now, one more thing. This is interesting.
Hello, Seva. I have one query. Like this related to rack awareness only, is there any kind of configuration required? It's self like internal process only. Like internally they will handle like we have 3 nodes and 2 node will be in one rack and other one is another rack.
So there is a configuration file. I will show you that file also. In that configuration, we set it up.
Okay.
Yeah. Any other question, guys? Okay. Now, another important concept is load balancing. Now, what happens is when, let's say, you added a complete new rack, which is full of servers, and maybe this network got added to your existing Hadoop cluster. Now, in this case, what's going to happen? I think somebody asked this question also, and I said, hey, hold on, maybe once I will talk about some disk balancer and the load balancing, I will be talking about that. Right now, basically, this is the answer for you. So if you have already some existing clusters, maybe you have like a lot of machines being set up, maybe you have this one rack, this is another rack where you already have some data sitting here, some another rack. And what you did, you came up with one more machine suddenly and said that, hey, this is my one more machine, which I'm adding it up here. And this is being connected with your system. So basically here we will have some switches, like this will be switch. And they all will be connected with a common switch also. So this is how basically physical level this whole thing looks like. Anyway, you need not worry much because this is not your job to look at it. But here, let's say all the data is sitting, but here there is no data because right now it's all there. It's a completely new one. So what happens in this case? So it doesn't mean as soon as you add this new rack, the data does not start spreading it automatically. The added server is going to remain idle with almost no data at the starting of it. Now the servers on this new rack are going to be then assigned some task, but there is no data being assigned to them. So if you have no data, even if you're sending some code, it's not going to be no sense, right? So what it have to do, it have to grab the data now from the network, which is definitely going to add some latency also because you are also increasing the traffic now, network traffic, and even the completion rate is going to become slower. So what Hadoop do? Hadoop have something called as SDFS balancer, which is going to balance your data among all the data nodes as well as within the rack as well. What does balancer do? It solves this problem of load balancing. In fact, your system administrator, whenever it required, they can run a balancer command. So there is a command line argument which you have to just run. In fact, I can tell you that command also. It's going to be sudo -u because it needs to be from the admin part. That's the reason you have to do it as a root user. HDFS, then again HDFS balancer. That's it. Once you hit this, this command is going to run the balancer with a default threshold. And what is the default threshold? Default threshold is 10%. In Hadoop 3.x, they have changed it, I think. I don't remember the exact number, but they have changed it slightly. But again, this number is configurable. What does this threshold means? This means that this command is going to ensure that the disk usage for each data node is going to differ from the overall usage in the cluster by no more than 10%, which means all the cluster will be balanced in a way that the disk usage in every data node will be just maximum going to differ by 10%. So this is what this command is going to help you to do. So that whenever you are sending a task, it should not happen that because of that task, everything sort of having the problem now. Okay. So basically that task should not be pulling the data from other machines and then we are increasing the network traffic. So that's the reason we are going to do this. Now, one more thing. Sometimes some people say that, hey, I want to change this basically threshold value. This happens a lot. So for that, what you have to do is just add one more thing to it. Let's say you can say hyphen threshold and put whatever number you want. I'm putting X, but you can put whatever number you want. So you can change it now. So let's say you make it 10 to 20%, which is also okay. I have made it in my project to 5% also because I needed the data traffic to be very well balanced. So it depends what's your requirement as well. So you can just define it. And in this case, whenever you will run it, your admin is going to run it. It will balance the data. Generally, we do it at the time when the basically network traffic is lesser. Maybe let's say your company runs in the morning. Maybe on that particular, let's say, even if I talk about Google servers, right? Maybe in Google, though it's a global company, but in the night, definitely for India's racks, definitely it will be lesser traffic in comparison to the data. So they can do all those calls at that time. And generally, it's not very frequent. It depends when we are adding these things. Then also we can do all this part. So definitely this command, but still take a good time when you're running it for the first time. Everyone clear on this part? I think Arun, you were asking this question or somebody else have asked this question. When I add a new machine, what's going to happen?
It was me, Shivam.
Okay, Girish, you have asked. Okay.
Yeah.
But you're clear now, right?
Yeah.
Okay. So this is about how we deal with respect to your load balancing. Now there is also another thing called as HDFS disk balancer. What does this do? So Hadoop is having this balancer and it helps us to solve the problem. Let me note this down. HDFS disk balancer. And guys, these things are very important when you will be doing maybe some performance and optimizations as well. Just keep these things in mind. A lot of times your code do not have problems. What we have to do is we need to really understand the configurations. And sometimes you tweak those configurations and you save a lot of cost. So especially people who have worked in big data from a long time and they work like an architect, they might be aware of all these configurations very well. That how a small change in the configuration can impact your overall performance and the cost. Okay. Now, what your disk balancer is going to do? It will help you to solve the problem of a non-uniform distribution of data. So what happens in your data node? So earlier that load balancing, which we have talked about, was more on if the new server was added, new rack was added. But here, what can happen that within the data node itself, maybe I have a disbalance of the data, right? So in those cases, this disk balancer is going to help you out. Again, follow the same thing. It can, even when you're writing a new block, a lot of times it can follow only these two policies. One is a round robin policy, where it says that your data node basically you're writing it in a round robin fashion, like one you take it to the disk one, then go to the disk two, then go to the disk three. Otherwise, there is another policy which states that available space policy. So depending on which machine, which data node have more space, go ahead and give that data node list right in that. So depending on the policy, generally round robin is the default one. But if you want to change that policy also, you can go in the configuration files and can change that as well. So irrespective of whatever policy you're using, but still it can lead to some problems. Even let's say if you are thinking to use available space policy, but still it could happen that in one node you are writing and deleting. So you are sending a lot of traffic to only one machine or to only one rack as well. Because you're deleting it also, every time a new request will come in, it will think that, okay, this machine is still free. Let me go ahead and write it here. So this will lead to a lot of input output in the same, and you're increasing your traffic on this. But one thing, this is not enabled by default. There's a configuration property for it, which is called as dfs.disk.balancer.enabled. So once you will set it to true, then this will be basically going ahead and enabling this up. Okay. Any questions on this part also?
Shivan, this round robin policy you have explained, right?
Mm-hmm.
Hello. Yeah, in this round robin policy, like how would the policy would work? Like first it will the block will write into a disk, and again the empty disk it will write.
No, I did not get your question, boss. Can you?
Okay, can just explain how, like, what is the round robin policy?
So round robin policy basically works like this. So let's say first time you got your block B1. Okay. So it will say, hey, go and write in data node 1, data node 2, data node 3. And because there will be, let's say, 3 replica, right? Let's say you write it here. Now let's say block B2 came. It will say, hey, go ahead and write it like this. Let's say block B3 came. Now you're getting the idea? How it is writing?
Yes.
So this is the way it will approach. But again, it has lot of demerits. Right? What if the block B2 was very huge? And maybe B1 and B3 were very small. So that way you maybe still overburdening of one data node.
Okay. Yeah.
Any other question from anyone? I hope all of you are able to understand it and nobody have to mug up a single concept here, because understanding of this concept is very important. If you get it, you will never forget it. It's very straightforward. Actually, Hadoop is very simple. It's just some concept which you need to understand. That's it. Okay, perfect. So we just understood now about all these systems, how they work. Now what we are going to do is, we are going to execute some of the Hadoop commands so that we can do some practical code for it. And once we are done with it, then we will move to the next component. So for this part, let me show you two ways to work on it. One is we can use this Cloudera VM box, which we can also use it here. For example, I can open this virtual box. I will give you a doc how to go about this. Let me open my virtual box from here. Okay. So this is your Oracle VM VirtualBox Manager. Similarly, you also have from VMware, also there is a VirtualBox for that as well. You can also use it. Now what Cloudera have done, they have already provided you some predefined sandbox where the whole Hadoop is already available for you. So you need not do any setup or anything like that. Let me just double click on it so that it keeps opening while I'm explaining this concept. Reason being, it takes a good time to kind of go about it. Now, so what's going to happen is, I will give you this file. What is this particular file? It's almost a 5.5 GB file. You can go ahead and put this down. So first thing is, go ahead and search for Oracle VM VirtualBox. You can easily get that. You can download it, some 150 MB file or something. Keep on double clicking, next, it will get installed. Once it is installed, now after that, once you have downloaded this, let's say this VM, which I have named it as Shivank VM, but you can name it as anything as you wish. So what you can do, you can click on new. Once you're done with it, just put this name, whatever you want to. Like for example, I have said it Shivank demo here. Now, once I'm done, then after that, what you need to do, you can say your machine folder where you want to keep this virtual box. What is the type? Change it to Linux, because you are going to have the CentOS operating system here. Keep the remaining thing as it is. Click on continue. Now select the size of your RAM. 4096 is the minimum. Is 4 GB is the minimum, but recommended size it's 8 GB. Now after this, click on continue. Once you're done, then basically say use an existing virtual hard disk. Okay. Now once you're done with this, select from here wherever you have saved that 5.5 GB file. Bring it here, just like you can see here, and click create. Once you click create, I'm not doing it because I already have it. Once you click create, it will create this icon left hand side like this. Okay. Now, after this, right click, go to settings. Now, from this settings, I recommend you to change this display scale factor. Sometimes it does give you 10%. So what will happen? This machine will open very small. It's not good. So just change it to whatever number, but make it more than 100% for sure. Now, you can also go ahead and from basically from this general part, just see that everything is all good here. Advanced. Go ahead in the shared clipboard and change it to bidirectional. Drag and drop host to guest. What we're doing is, if I have to copy a file, let's say from a local machine to this virtual box, I should be able to do that. So that's why this is drag and drop. Now, even in systems, if I go and look at the processor, so right now I have used 2 CPU. By default, it remains as 1. But in case if you want to improvise on the performance of your virtual box, increase it. I have less CPUs, but you can go to 4 CPUs if you have it. It will increase the speed for your internally as well. Rest of it, leave it as it is and click on OK. Once it is done, double click on it. It will open the operating system for you. I will give you a document anyway. I will share it with you so that you have all the steps handy with you. But any question on this part? Okay. And irrespective of any operating system, you can do this. If you have Windows also, doesn't matter. So what we are doing is, on top of any operating system, we are sort of bringing a CentOS, having all my things available inside it, like all the Hadoop is set up, everything is set up. I will also show you the cloud way, right, which you can also use it. Basically, I think everybody must have received the ID. Anyone who have not received it yet, let me know. Everyone have received it, right? Perfect. Now, yeah, Karthik, you're saying something?
Yeah, which ID you are talking about?
So you must have received the cloud credentials to log in.
No, I have not received cloud credentials.
No, Shivanka, I need to. I didn't receive.
Even I haven't
We didn't
received
receive any cloud.
Okay, let me just quickly confirm from Satish and Lakshmi. Lakshmi, can you please confirm on this part?
I think some of them have not received the last, people who got nominated at the end. So you guys don't worry, you'll get your credentials. Whoever has not got your credentials, just send out an email to Girish, please.
Sure. Yeah. Yeah, that would be helpful, Satish, because from tomorrow it's going to be very aggressive lab. So before that, we need this.
Yeah, alternatively, what we can do is that you can share this a VM with these guys. They can install it if they're not going to get the credentials by tomorrow. That should be also be okay, right?
Yeah, yeah. That should be perfectly fine. This VM I will upload.
Satish, to install that VM, we have some administration issues.
Okay, you have to get in touch with IT team for that.
Yeah.
Okay, thanks.
Yeah.
Or else, alternatively, what you guys can also do is that you can create an AWS free account or an Azure free account. You can also spin up a virtual machine there, and then also you can do that.
Yeah, that will work.
All right, guys.
Yeah, Satish.
Yeah. Let me also just quickly log into that lab and show you how that looks like. Okay, when you will receive the email, it will be something like this. Okay, mine is a very demo account. So you can see here that it will give you this part. You can log in by providing, let's say, whatever credentials you have. Let's say it's with the name Lakshmi, and whatever the password you will be getting up, you can also click it from here. Just copy paste all this. And you can sign it. Once you are here, you should be able to see this view lab option. Click on it. It will open up something like this for you. Now from here, you can see so many things. One is Hue login, which I will show you what is that. Second is a web shell. Third is Jupyter Hub, which we will use it when we will go to PySpark. And this is Cloudera Manager portal, which we don't need it. It's basically all the what are the services running. I will show you what it is, but we don't need to do anything. Now, let me log into the web shell. So when I go here, you can see that it have given me a username. So let's get that. I will say this login. Then after that, I can copy my password here. And now I'm inside my cloud. Okay. So this is my cloud environment, which is given to me. Now, second thing is, if I want to go to my Hue shell, Hue is a user interface for your Hadoop environment. Here also, I need to provide the username and password. Let me first copy the password itself. Let's get the username also. Now you can click sign in. So this is your Hue interface, which is like going to be a user interface for you. And I will explain all this interface in detail. Okay. So from here, if you click on this and go to your files, you can see all the files being present inside your HDFS. Right now, there is no file because we have not done any activity. But these are the two things what you need for today lab. Your like all the shell commands which you can run and your Hue computations. Now let me show you here. So you can execute all the commands which I'm going to hit on the VM from here as well. There is no difference between them. Okay. Now let me bring it here. Perfect. So to start with, what we are going to do in this case, let me make this here and open my terminal. So this is my terminal, same way how we were seeing into the Cloud Lab as well, and we can do it. Now for connecting to Hue, you will have a browser already running. You can just click on this Hue. You don't need to do anything. It's already being given for you. Just click on this Hue button. And you can see that you are connected here, right? Now, by chance, if it asks you for the password, you can give admin, means username as admin, password also as admin, in case if it asks you for that. Now, once you're done with this, you can see from here also, I can click on this, go to the files option. This Hue is going to be very helpful even for the further activities. Here I've created some files. That's the reason it is showing up in this case. Now, let's go back to my terminal. Let me make this a little bigger. Okay, I hope all of you can see this now better way. Now, what all things we are going to hit today? So we are going to just look at some basics levels of Hadoop commands. That's going to be the intention right now. So that at least we have a kickstart with this, because everywhere we will be using this up. Now, first thing first, once we got this machine ready or in the other lab, and if I want to see all the commands which are sort of available inside it, I can say Hadoop fs -help. So what it's going to do for me, it is going to return me all the commands and details in the Hadoop. You can see it here, right? You can go up, you can see -text option, touch Z option, tail command, test command. Every options is given, like even set rep, I will be using this. If you want to change the replication factor, how you can use that. So all these commands you can go and read it from here. Now there are two ways to that. If you're running it in the local file system, like I'm doing it up here, you can use the FS, or you can also done it with a distributed file system, which is the DFS. Even you can see this is working. Sometime you will also see this command being used as HDFS DFS, like instead of Hadoop, sometimes you say HDFS also, which is also fine. So anyway, you want to run it off, it is completely fine. There is no problem with that. Let's start with the first activity. So I'm assuming here that everybody is well versed with the Linux command. I've already given a link also for that. Is there anyone who is not aware of when I say what is ls command? What is mkdir command? Is there anyone who do not know these basic commands? Please don't hesitate to ask because I can clear it in 5 minutes and then go forward. Otherwise, everything will be alien for you. Okay.
Can you once again refresh for me, please?
Sure, no problem. So what happens is in Linux, you have some commands. For example, if I say ls, it means list my files in this directory. So you can see here, it have all these files into it. So in your Windows or something when you're working as well, right? A lot of times what happens is you go and view those files into a directory, right? For example, let's say if I open something here, let me just quickly show you. So let's say if this is my desktop, in this desktop, can you see that I have two files? One is screenshot something. This is also a screenshot. So that is what is present inside this folder from a UI side. But what about if I want to see the same thing from a console? So for that, I say ls and I can see in this file. Now, if I want to quickly see that in which directory I am, I can say pwd. So pwd will tell me which working directory I'm being present, and this will help me to basically execute and check out this file. Okay. Yeah, you can see I'm being present inside /home/Cloudera location. Now I want to create a directory inside it. Let's say I'm going to say, hey, create an mkdir, and I want to create it by the name Arun, let's say. So now if I do an ls, you can see that Arun named directory got created, though nothing will be inside it. Now, if I want to go inside Arun directory, I can say cd Arun. Now I'm inside Arun directory. And if I do an ls, right now, nothing is showing up because Arun is a completely new folder where nothing is present. So that's the reason you can see that there is nothing coming up here. If I want to remove something or if I want to create a file here, I can also do it by using cat, or I can use do it also with the help of vi operator as well. I will show you while running the file itself that how we can create a file as well. But this is the way we can have some simple ls command. You want to remove some file, like let me quickly show you anyway. Let's say if I want to create vi a.txt. So what it will do is it will create a a.txt file. Now I'm inside it. This is a vi editor mode. Now, first thing, if you want to type something, it will not work. So you have to click I. I means insert. You can see also below it starts showing you insert. Now you can write whatever you want. Let's say welcome to big data world. Big data world. Now you want to save this file, click escape, colon. You can see here all the things which I'm doing is showing up here, colon, WQ, exclamation mark, means quit after writing. Now you can see if I do an ls, we can see a.txt getting created. And if I want to read this data, I can say cat a.txt, and you can read this also. So this way you can also read these files. Now, one more thing, if you want to do, if you want to come back from this directory, you can say cd ... It will come back by one location. So now you can see you're again in /home/Cloudacre from /home/Cloudacre/Arun. Okay. So you have changed this directory. Now what you want to do here, if you see, we don't have any a.txt, right? So what you want to do is you want to bring this file from Arun directory. So a.txt to your current directory, means in this location. So what you can do, as soon as you will hit this mv command, it means move, means cut paste, not copy paste. So now what will happen if you do an ls, you can see a.txt showing up here. But if I go inside Arun again and try to find this file, it's no more. Clear how this works?
Yes, it's clear.
Now let's go ahead and try to see how we can work on the HDFS systems now. Now, first thing first, if I want to see the file present in my HDFS, I can simply hit Hadoop fs. Sorry, I don't know why it was not typing. Okay. Hadoop fs -ls. Now, this is the way we will be defining it. Any command we will be writing, we will be starting with Hadoop FS or Hadoop DFS. And then we will be defining the command which we want to. So you will find a lot of similarity when it will come to Hadoop and the Linux command. Not everything will be same, but there will be a lot of similarity in this case. So now if you say Hadoop FS-ls, you will notice that you can see these files. One is your basically free folder and one is a T. Reason being, I've just created it for testing purpose before this session. But surprisingly, if I do an ls, I have nothing here. But here I'm able to see this. Why? Because it is going and read these files from the default location of your HDFS. Now this default location of HDFS is configured when your Hadoop is installed. Now definitely, even this, I will also show you maybe in some time that where these files are being stored as well. But just to give you the context, I already explained you that even when you say HDFS and store something, you are still storing it on your local machine. If you are running on the one machine system, if you are working on a name node, data nodes across, then it will be saved on some data node machine as well, where it will be located in some directory, right? And that directory will be dependent on the configurations you have done. So now in this case, it will be some default location from where we can see this. In fact, if you recall, when I showed you the hue also showed me something like this, right? Can you see here? This is the location /user/Cloudera, and this is basically the same files what we are seeing there as well. Let's go back. Now here, once I hit this, so I have not even given this path, right? I have not said /user/Cloudera, which I can see from a hue that this is the default location. But so what happens is if you don't define any location, it will be going to the default location which you have configured, which in this case is this. If you want to give the full path also, you can do that. So you can also say that /user/Cloudera, and you can see those files as well. So as you can see, it's exactly giving me the same output with no difference in it. Any question on this part?
Yeah, sure. Like if there are multiple clusters, like if there are multiple data nodes, so the default location would be on a name node, or is it in HDFS client, or?
You mean to say if I have multiple, see, it is going to be configured in a way. Let me explain you. So let's say you have this name node. These are your data nodes. Okay. So let's you say that, hey, I want to read the file, which is basically the default location. So for every machine in the configuration, you will have the default locations, right? So it will be going ahead and will be returning the results basically from all the places for you.
Yeah. So like if I give the command Hadoop FSLS, so the default location, which location it will show? It will show the name node.
Let me just explain you that. So what happens is that your basically when you are going to it, there is a user authentication for you. Okay, you have your own user. Let me show you. In fact, we already have a cloud. This is a 3-node cluster which we are having in this lab. So if you look at this one also, what happened is you have a location which is /user/Lakshmi, let's say 1706. Okay. Now for this particular configuration, basically for this part, it will know, let's say if I get back to this. So maybe here it is configured for Lakshmi, maybe here it is configured for Lakshmi. So it will know that where all this user Lakshmi basically data is sitting resides for me. So whatever the default location for the machines will be there, for that particular user, it will be returning to you.
Okay, yeah, got it.
Now you got that idea? So
Yes.
I've actually not gone into this yet, but yes, this is going to be important. Since we have this lab.
So whoever the user using that in that machine, that user's default location will be displayed, right?
Yeah. So let's say for you, it will be different one. So when I will be uploading the data here, I can only see my data. Now it depends on the permissions also given. For example, let's say if I come back here in /user, I can also see so many users created by this cloud people, right? Now let's say, let me see if I can, let's say, go to admin. So I can see this file also. So it depends, like if I have the permissions to also read it, it depends how these people have also configured it as well. So like big data prop, they have given me permission to read it here as well. Okay. So this is the way we look at it. So it depends, but by default, you will be only going in your location.
Yeah, sure. Got it. Thanks.
Now, any other question from anyone on this? Okay. Let's say I want to view the space usage of the SDFS using the du command. I can do that. So I can say Hadoop fs -du. So what this will tell me, this is also a Linux command only. People who already are coming from the Linux part, they will be aware of this portion. So this will be checking the space usage of the SDFS. Right now, actually, I just created some directories. I have not kept anything inside that. That's the reason it is telling me it's or completely blank, right? 0 bytes. And it tells you in the bytes format. If you keep some file inside it, it will tell you that, okay, you have already occupied this much of space for in this particular directory, or this file is occupying this much of space. So this is the way you can also see this thing. Now, what I want to do is, I want to create a directory inside Hadoop. So I will say Hadoop fs -mkdir. Again, you can see this is just like a Linux command. Let's say I want to create as a trial account. Right? I have not basically done anything for a trial. So I said I want to create for a trial directory. So now if I hit this, because here if you see, I only have free and T, right? As soon as I will hit this, okay, sorry, there is a typo here. Now, if you want to view it, I can say again, Hadoop fs -ls. Now you can see also a trial thing coming up for you. Let's go back to my queue also quickly and see the same. Let's refresh it. So you can see here that trial is showing up. If I go inside it, there is nothing because we have just created this particular directory. There is nothing present inside it. Now what I want to do, I would like to send some data in this directory. How I can do that? I can first of all, let me create a file and insert some data in it. Now, in order to do that, I have just shown you a vi command there. Now let me show you cat command. I can say cat pipeline operator means I'm going to send some data now into a file. Let's create it, let's say by saying test.txt. Okay, I'm just creating this file. Now inside it, whatever you want to write, write it. So let's say I say, hello, welcome to big data world. We are enjoying it. Now you can come out of this by saying Control Z. Now once you're out of this, now you can see cat text.txt. Now you can see the same data showing up for you. Now once you're done with this, I would like to send this text.txt file to my HDFS, because right now if you look at it, this directory of trial is empty. I want to send this file now to this particular directory. How I can do that? So you are going to now say, open this. Now you're going to say Hadoop fs -put. Now which file you want to send? You're going to say text.txt. If I'm in the current directory, otherwise you have to give the full path. Now you can say trial, and inside that you want to save it by what name? Let's say you say that I want to save it by the name trial itself. Okay, just randomly. Now let's see what's going to happen. Now, if you go here in your queue and refresh it, now you can see here you have a trial file coming up. So that file name got changed to this. So you can, if you don't define anything, it will save with the same name. But if you define some name, then it will just replace that name. It will rename it for you. Any question till this step? Okay. Can you tell me how many of you do not have the lab with you?
I'm not having it.
Karthik, anybody else?
Not having it.
Ishwar?
Yeah, I am also not having.
Not
I'm
having.
also not having it.
Okay. Some five, six,
Not having it.
okay. Some 5, 6 people don't have it, but the remaining people, can you quickly open your Cloud Lab? In fact, people who do not have it also, can you do one thing quickly? You can still, maybe you guys can share the credentials also. It will be fine. I think you can log in from 2 accounts. That should be fine. Because we are not doing any strange activity. Just create your folder with your own name. And work on that. So don't create it, let's say, just like how I created trial, maybe you can create it by your name. Let's say Arun can create with his own name and can work on that. So that should not be a problem. I think 2 accounts can open at the same time. If you want, you can also access this one now. I can show you this one as well. Can you all quickly try with this, whoever do not have it? I'm giving you this link on your chat. 1 second. I just gave the link. Can you just try with this, guys? So what I want you to do in just right now this exercise, I want you to first of all ensure that, okay, you are able to play with your simple Linux. Then further to that, I want you to create a directory in your HDFS in /user / or whatever your home directory is. Make sure you are able to access your hue also in that and create a directory inside that and put a file inside that. Okay, same thing which I have done, but you have to just try it with your own style now. So that I just want to ensure that your hands get dirty with some code to start with. This is very beginner to start with. Later things will become little complex. So you should be very comfortable with the beginning things. So people who are trying on my lab, let me know in case if it do not work for you. Just ensure if you're creating a directory on my lab, use your name. And whoever is done, just type in the chat box is done once you complete it.
Shivank, I'm using this learning desk, Lakshmi's learningdesk.com, but it is asking for Cloudera Manager password and username and password.
Okay, so first of all, when you have clicked on this link, it had asked you to provide the username and password, right? Have you entered these username and password, which is given to you?
Yes, yes.
Okay. Then after that, can you see this thing?
Yes.
Okay, don't open this one. Click on this web shell.
Okay.
In web shell, you have to provide this username and password, which is on the left side. Same way, open the Hue login.
Okay.
So, like, first we have to enter into the web shell or the Cloudera QE login portal?
Yeah, so you have to just click on this Cloudera Hue login portal like this. Just click on this. It will open as a new browser. And once it will ask you the username and password, just provide that.
Okay. Okay.
For people who do not have the lab, I have already given you basically here. So you can copy paste to login at the first one. Then after that, you will see the screen only. If anyone face any trouble, please ask. immediately. And don't think any question is basic question. You can just keep asking. I will keep answering you. If you are not able to understand that, I will tell you in different examples.
So Shivan, here you can tell in which format the files would be stored, because here when you showed, it was a text file that you try to move it to HDFS, right? But there, in which format the file would be saved?
So in your HDFS, by default, it will take the whatever format you have. Otherwise, it will be TXT format. Okay. And I'm also going to discuss very soon tomorrow once I start with Scoop on the file formats also, that what exactly do. There are a lot many formats which Hadoop plays with, like especially sequence file and Avro is very important to understand. So I will also tell you how you can change those formats to save it here.
Okay. So here, do we have any command while we try to push like Hadoop put command and try to change the format of the file that we save it on HDFS?
For that, just hold on. I will be explaining actually in detail.
Okay. Okay.
How we do all that.
Okay.
There's an optimal way for this.
So Shivang, after login into Hue login, we have to open web shell, right?
Yeah. So one, you have to open these two windows. One is a Hue and second one is a web shell.
So in web shell, it is asking for something npbdh login.
Okay. So once you click on this, it will give you something like this, right? Login. Then after that, come here, copy this. So this is your login username. Then after that, it will ask you password, then copy here, then again.
Okay, fine.
Okay.
Shivank, I'm unable to give this password in web shell. It asking like npdh login. When I'm trying to paste credentials, it's showing like session closed.
Session closed. Login with mine or
yeah, yes, login with your credentials.
It should not. Let me try it. Okay, then I got session closed. Maybe you might have given a lot of time for it. Let me just try it in front of you. Let's say if I go to my web shell.
Yeah, I'm seeing.
Let me copy it here. And I can give this login. Now it's asking me the password. I can come here and put the password quickly and done. This is working. Maybe you've given some more time, right? As you saw that even for me, it showed the same thing.
I'll try now.
After you have placed on the file, just try the du command. It should show you the disk sum taken up by that. If you recall, when I did that, it showed 0, but it should be in your case something else. And also guys, if before tomorrow class, it would be great if you can all have the Cloudera VM setup. At least this would be a great help, because I will give you some data sets to upload. That's going to be huge data set for your case study. And I want you to work on that. So maybe in the starting of the class itself, I will ask you to go ahead and upload your data sets, so that it takes around an hour to get loaded, around an hour or 2 hours. So by the time we will reach basically to our the case study, you will have your data set up and running.
So Shivam, what is the location where we can download that VMDK file for Cloudera?
I will be giving you Google Drive. We have not yet created it. So it's me to create that. So I will pass it to Lakshmi, and Lakshmi will be passing it to Satish, I think, immediately. And maybe I can create while you guys are doing it. At least you have the link with you, and you can maybe keep on doing it later, right?
Yeah.
So you guys keep working. Let me just upload it here for you guys.
Hey, Shivam. Hello. Hello. Shivam.
Yeah, you can hear me.
Sorry, Shivam. Sorry, Shivam.
Yeah, you can hear me, right?
Yeah. Actually, I have a doubt. I created the file by using, in web shell, but that file is not reflected in the hue.
Okay. Can you tell me what is the command you have given? In fact, you can do one thing. You can share your screen right away.
Yeah, sure. 1 second.
So guys, whenever you have any doubt, you can always tell me if I can ask you to share your screen. That will be better.
You can able to see my screen right now?
No, not yet.
Okay. Host disabled. I think you have to give the permission to for us to share. It's not. It's saying that host disabled participating screen sharing.
1 second. Let me see if I can do something here. There is no option also. Okay, can you tell me what is the command you're doing? Before tomorrow class, I will get the fix.
Actually, like a first.txt.
Sorry, your audio got little breakup in middle. So can you type your command in the chat box? What do you hit the first command?
Yeah. 1 second. I first created the directory by using my name.
You have sent the chat.
I given the commands which I used by one.
Okay, so let's do one by one. So when you NKTAR Grishma, in that, go to your view, are you able to see your folder Grishma or not?
Yes, I am able to see my folder.
Okay, that's awesome. Now further to this, you executed the put command?
No, I executed the put command after the creation of the
Okay, can
folder.
You send me the command? What's the put command you have placed up?
Yeah, 1 second. After creating the file, I given the put command.
Yeah, can you send that put command?
Yes, sure. 1 second. This is the put command I given.
hdfs fs -put first.text. Okay. Can you say Grishma / and give some name?
Okay. It's showing that no such file or directory.
Just check whether your first.text is showing up to you or not. Let's do an ls.
Okay.
If not, you can quickly create a new one. That's not a big deal.
Okay.
And give the extension as txt, not text, because text is not the right extension.
Okay. Oh, sorry. I think I given wrong. Okay, I will try and I will come back.
Okay. Anybody
Thank
else?
you.
Any issue, guys?
Shivang, just create a text file and move it into that folder, right? Using put command.
Okay. That's what you have to do.
Okay.
So Shiva, how do I create the file using a cat command?
No, you don't create it using cat command. In SDFS, that don't work.
Okay.
It has some similarity, but not everything.
Shivank, actually, the connection is not getting connected. Like it's saying it's someone, two people are trying at a time, right? So that is why I think it's not showing. It's initially got connected, but now when I'm opening the web shell, it's not showing me.
Okay, it should not happen like that. Multiple people can connect. You can do one thing, Ishwar, just think somebody maybe fill in this. You
Okay,
can,
like what's the login again I have to give, like for the when in the shell box?
yeah, in the shell box, you have to basically I just gave you this thing, right? That there's a link, login ID and password, right?
Oh,
Immediately,
the same one.
yeah, same one. Just try that.
Lakshmi at the rate, is that one you're saying?
Yeah. Just try with that again, it should work. Also, meanwhile, I have already just going to put that down. Load also, correct?
So Shivan, can we have those credentials shared by tomorrow or before the class?
Which solution?
This Cloudera.
I'm just
Because I'm not sure whether team would be able to install VMware, because considering this is weekend, and also most of them don't have access to install software.
So in case if it do not work, what I will do is I will maybe postpone the case study to Monday class or maybe Tuesday class, because you need Monday to get this done, right? So maybe I will start a new topic and the case study I will Tuesday.
Okay, or else I'm not sure whether, because right now we are trying to use your credentials, and it will be more than 2 logins, right?
Getting it from Lakshmi by today itself. That she will take care of.
Okay.
Yeah. These credentials you will get it. It just for today, I just want to ensure that whatever we are doing, you should just get your hand dirty and get confidence in it.
Yeah, right.
So we're just creating the file in Hue. Is that right?
Yes.
Sure.
Yes. Are you done with that, Arun?
Wondering how we are creating the file.
Yeah.
So, Shivan, how to open that browser?
You mean to say Hue browser?
Yes.
So if you come here, let me show you. When you have logged into this portal, right, you will see this Cloudera Hue login portal.
Okay.
You have to click on this and then give this username and password, which is on the left hand side.
Okay.
Once you do that, you are connected. And once you are inside that, then after that, you have to just go to the left hand side, these 3 icons, click on this, click on files.
Okay.
Okay. Once you click on this, you will be taken here. You can see all these files.
Okay, good.
I already see a lot of you have created it here, which is good.
So are we creating the file in Hue portal, or how are we creating it?
I did not get your question. Can you say again?
The test file we are creating, the text file, are we creating on Hue portal, or how are we creating it?
No, so what we are doing is we are sending it to the HDFS. Remember that whole theory which we have done? So we are sending to a data node. Now what is happening? That data node data, we can view it using Hue. So Hue is nothing but a UI interface for you.
Okay.
So that's the reason you were doing it with the command line, right? You must have used SDFS, DFS -put command.
So Shivang, one doubt. By using Hadoop command, if we want to like change directory to say Karthik, can we do that?
You mean to say you want to rename the folder?
No, not rename. Like I am in we are in present working directory, some present working directory. Now I have created a folder, Karthik. So I want to go into that folder.
Okay, so there's no CD command here because ultimately you are not inside your Hadoop machine. Your data node is sitting somewhere else, right? Remember that architecture data, you are a user client. As a user client, you are sending your request to SDFS client, right? You are not at all sitting inside any of the. Now, due to what is happening, that HDFS client is sending your request to the data node. So there is no CV which you can do now, right? Because that's a remote machine.
Yeah, I understand now. So basically, this Hue editor which we have opened, from here we can go into our folders and check the files, right?
Correct. Can you all, how many of you have finished it in fact? Okay, Pradeep have written I'm done. How many others are done?
I finished, Shivank. Aditya.
I finished.
I finished, Shiva. It's coming.
The last 2 minutes, can everybody else also quickly finish it? We have to still do some more lab activities today.
Yeah, I also mentioned.
Okay, just last 2 minutes now. If anybody face problem, please immediately ask. This is the very beginning and you have to ensure that you kind of are excelling in that.
So yeah, I'm still lost on how the source file was created.
Yeah, please ask. So which source file you are referring to, Arun?
So the file we're trying to move into the folder, the directory we created.
Okay, so let me just quickly show you. That's not a problem. So let's say if I'm in my VM, now from here, I can click on this. I can say cat. Okay. Basically the name of my file. Let's say I say arun.txt. Now, sorry, cat, this pipeline operator, arun.txt. So basically what it will do, it will be sending the data to arun.txt. Now, whatever I want, let me keep placing it. And once you're done, do a control jet.
Okay, got it.
All right. Can you quickly finish it now, Arun?
Yeah.
Hi, Shwank.
I think.
Yeah, actually, I'm trying to log in web shell. After putting the login, I'm not able to paste that the login username and password. Their question mark is coming.
You can type it then. That should be okay. I know it's a little tricky, but you can.
Okay.
Also try it on a different browser. It should work, I think.
Okay.
Shivank, when we are using this cat command, we are simply creating a txt file. So this file is not getting stored anywhere.
No, it
right?
is. If you see ls, if you see arun.txt showing up, it is getting.
Okay, ls.
Yeah. And if you want to read,
If
you can say cat. Don't give any pipeline this time. Just say cat this. This is getting also. So if you give this pipeline operator, it means insert the data inside it. If you don't give any pipeline, that means you want to read it.
Okay. So we are giving ls command, then it's showing it. But if we do Hadoop fs command, then this file is not there, right? So this is getting stored in our local machine or something like that.
So be very clear on this difference. Whenever you are creating some file, you are doing it on your local file system. Okay, so you are doing it on a local machine. When you are hitting this command Hadoop fs, then you are actually doing the operation on your HDFS now. Means you're working on your data node. So think of it like this. Let's say you have in your machines /user / maybe Arun, right? Let's say this is your local machine. Similarly, on your same machine, there will be some other location. It will be like /home /Cloudera /opt. It might have created such a huge folder, and within that there will be a folder for your data node. So if there all these files are going. So all the operation when you are hitting with Hadoop FS is going here. And when you are doing the local command like ls, cat, these operations are happening on your local machines. Getting the idea now?
Yeah, I understand now.
Guys, can we go ahead now with the next step? If you're not able to yet complete, you can try it after the class also. And if you face any trouble, we can start tomorrow class also with the same. I will also give you some more time even in the last to complete it. So you can even ask me at that time. Now let's go ahead with few more things. So we just understood now how to load the data. Guys, I need your attention now. Okay. So we just understood how to load the data. So we saw Hadoop fs -ls, and we have seen all these folders showing up now for me. I think now it will be much more because you guys have also loaded some data for me. Let this get executed. Now you can see I have a trial folder, and inside that I have few files as well. So let's say if I do a trial, it will give me the results inside the trial folder. It's taking a little more time. I don't know why, but that's okay. Now you can see this, right? So inside that I also have a file called as trial. Now what I want to do is, so right now if you do this in Arun folder, I don't have a file called as trial, but in my HDFS, I have a trial file present, right? So now I want to bring this file to my local file system. So using the put command, I send the data from the local file system to my HDFS file system. Now what I want to do, I want to bring the file from my HDFS to my local file system. So when I hit this ls, so this is my local file system, right? And when I did this Hadoop fs-ls trial, so I was looking in the Hadoop system, in the HDFS system, I was searching for that. So now I will say Hadoop fs-get. Now I will say, what is the file I want to bring up? So I want to bring up from trial folder, and I've also created a trial file inside it. And I want to save it in the current directory. Let's say I want to name it as trial. Let's execute it. So now what it will do, it will bring the file from my Hadoop file system, which is this one, to my local system and name the file as trial1. Now if you do an ls, can you see trial1 showing up here? So this is what get command will do. It's the opposite of your put command. Any question on this part?
What if we don't want to change the name? Like you just give a dot over there instead of trial1?
If you don't want to, you can just say dot. It will bring up.
Okay.
Or you can give the same name also, right? You can also say trial. That's also is fine.
All right. Okay.
Any other question on this?
Can you explain that command once again?
Sure. So what happened when I did a put command? Using a put command, I was sending the data. Let me show you here. So what happened using the put command? So using the put command, I was sending the data from my local machine, which I created using the cat command, to my HDFS, right? But using the get command, I was doing the reverse. I said, send the data from my HDFS to my local machine now. So now you can see what I'm going to do here. I'm saying Hadoop fs-get. Now recall that trial/trial is the file which is present in my HDFS, right? If you go to your queue also, you can see that. So here, if you go here, can you see inside the trial, we have a trial file. So that's the reason it's written as hello, welcome to big data world. We are enjoying it, right? So this is the file which I want to bring to my local file system. So what I said, this one, and I just said that, okay, save it with the name trial1. So it brought this trial with a different name as trial1. And you can see here, when I did an ls in my local file system, I can see that trial1 present for me. Clear on this part now?
Yes.
Anyone have any other question on this? Everyone clear? Perfect. Now, let's again see this. Hadoop fs-ls trial, and let's execute this. Now look at this part. What is happening here? By default, this trial file has some permissions given to it. If you do not know chmod, really don't worry about it much. This is to give the permission to the files in Linux. So for example, here to the user, I have a read write permission. To others and to the group, I have only read permissions. That's what denoted by R. Now, if you want to change this permission, so what we do is like we can define it by using chmod. But let's say if you do not know chmod, please don't worry about it much because it is not very much required. If you know it, you can understand this part. I will say chmod, and I want to give a chmod permission as 700. If I give 777, that means I'm giving read, write, execute permission to everyone. Okay. But if I'm giving 700, I'm giving only this permission to my user. Now, to which file I want to give? Trial, right? Which is present in my Hadoop system. Let's execute it. So these commands, the chmod command also is applicable for your Linux also. So now, if you again do an ls of trial, now, can you notice the difference? What it said, it has the read, write, execute permission. X means execute permission for the user, but for all the ones it became 0. Means for the group as well as for the others, it became 0. But here we had a read permission also for the others and for the group, and for the user, I only have the read, write permission. But now I have all these 3 permissions by defining 700. Clear on this part? Means if you do not know chmod, do not worry about it. If you know chmod, then you can understand this part. If you do not know, I can maybe tomorrow class, I can bring this up again. That's not a big deal. I can explain you what chmod do in detail. Like there's some values we define like 4, 2, 1, and that's how we add to 7. But I will explain you in tomorrow class then, because for this I need some more time. Now, one more thing which I want to show you is, let's say if I come back here, I can hit this Hadoop. You can see Hadoop here. You will not be able to see this in the Cloud Lab. Basically, there it will not be allowed for you. You can click on your HDFS name node. Now inside this, you can go to utilities and you can say browse the file system. This is basically getting connected from the name node. In the cloud, I think you might not have the permission to go through it. So here you can see this is user/user. Now, after that, I can quickly go and check the Cloudera /user/Cloudera. Now inside that I have a try, right? Let's go there. Can you see the replication factor for this file is 1 here, right? Replication factor for this file is 1. This is I'm looking from the name node portal. Now I want to change it to something else. I want to replicate it. So what I can do, I can say Hadoop fs -setrep. Setrep means set this number, new number. Now I want to change it to let's say 3 and I want to say trial/trial. Anyway, since you are working on a single machine right now, this may not have any impact. But if you're working on a cluster like in your Cloud Lab, then this setrep will change for you. Means it will copy it into different data nodes. Now let's execute this. Now you can see it's saying that replication has 3. And if I come back here and refresh it, you can also notice your replication factor change. Any question till this step?
So does this mean the replication can be done at file level?
Yeah, it will be at the file level.
Okay.
Any question, guys, on this part?
Shivank, initially you had set this replication factor to 2, right? So in that case, we could have created 2 copies across the cluster. And now since we have changed this to 3, it would have simultaneously created the other copy in the other data nodes, right?
Remember the write architecture? In that write architecture, what used to happen? You are going to send this request from the user client to your SDFS client. Now SDFS client will go and tell it to name node, and name node will know that, okay, earlier replication factor was, let's say, 2. Now it will say that, hey, you want to maybe create one more copy for it. It will send this lease request for it. And it based on that, it will send you the data node list also, which is going to be just 1 in that case. So now you know that, okay, you have to write it only to one machine and you can write that. Got it? This is how that write will happen when you are asking for a new replication.
Okay, what happens in case where we don't have enough storage and we would change the replication factor? In that case,
if there is no storage on that, but generally, basically, if you have this sort of problem, what it will do is like it will return a failure, and it will quickly look at the other data node. Remember that failure scenario which I also explained you? It will send back from acknowledgement queue to the main queue again, and then again it will inform name node. Name node will give a new data node part, and then there it will again try to write.
Okay.
Clear on this, right? How it's working? Again, you have to keep this architecture in mind. That's what is very important. Whenever you are visualizing this command, keep that architecture in mind, how it might be writing at the back. Guys, any other question from anyone? Okay. So I still have few more commands. Maybe I will get back on this again tomorrow. Let me open now the forum for question answers. Anyone have any sort of questions on today's topic, whatever we have discussed? No questions?
Shiva, so the replication command you ran was in VM, right? And the VM only has one data node, right?
Yes.
So in theory, are we breaking the rule that a data node should not have more than 2 replication at any time?
No. So what happens in this case is it don't create a new copy for you, but name node mark this. It's stating that, okay, this file is under replicated. Now what happens whenever you will add a new data node to your cluster, now whatever you have marked at that time, it will start replicating those data for you.
But the acknowledgement to name node will be already sent, committing the data to the metadata.
No. So that's what I'm saying.
So it's not going to be done.
Yeah. So I'm just going to explain you here. So what's going to happen is, let's say you are only having one data node, right? And you already have a copy here. So when you from your client, you send the request to SDFS client, it sends to the name node. As soon as name node will receive it, it will know that I have only one data node left. It don't have any other data node copy left out. So what it will do, instead of sending you the lease, it will mark it here that, okay, this block is under replicated with me. So it will not send the acknowledgement, because we will not even reach to the further stage. It will not let you write the data. Got it? And it will just send this part that, okay, I've just marked it as under replicated.
and if the replication factor is reduced to the actual number, then it would be deleting those copies in the data nodes, right?
Then it will be going ahead and deleting that. Any other question, guys? Okay. Just want to get a quick feedback from all of you. So whatever we are understanding, everybody is able to catch up every concept with the way we are using the whiteboard and everything. Anybody facing any trouble with this?
Guys, speak out.
Because this is the first class, so it's more easy to change it.
Yeah, sure. Like, I'm able to get the concept and clear the concept. Yeah.
No issue, Shivank.
Aditi, you said something. I couldn't hear you.
I told no issues with the whiteboard.
Yeah, this is the whiteboard.
Yeah, I mean, we can understand. I can understand, so.
Sure. Lakshmi?
Yes, Shivank.
Yeah. So I'm done with the session. You have anything?
No, all clear, Shivank. I'll get a feedback and also pass it on to you then.
Sure. So maybe I can sign out in that case. Guys, we will connect again tomorrow. Maybe.
Shivank, is there any document you said, right, you will provide in Google Docs? Can you provide that?
Hi, very good question. Thank you for stopping me here. I have already created it actually, and I was completely missing it out to send you.
Okay.
1 second. I'm just sharing with all of you. Even the data Cloudera cluster is also uploaded for you there. Let me share the link. Okay, looks like it is not yet uploaded. It's still uploading, but I can give you the link at least so that you can start using it. Just 1 minute, guys. It's working very slow because it's uploading a huge file.
So Girish, Karthik here. How should we proceed with those? Like we don't have Cloudera IDs. So what should we do? Like we should install that VMware, or how should we proceed with it?
VMware, I'm not sure whether you can install Karthik because you need to have admin access. So Lakshmi,
Okay.
I assume you would be sharing us the credentials by today.
I've already shared it yesterday for all of you. I got a participants list. Did you get it from Mahesh?
Few of them have received it, but the other team members are still waiting for the credentials.
Who are pending? Girish, can you let me know the names? I can make a note of it.
Yeah, I can send you the list.
Okay. You can also make a note of my number, Girish.
Mm-hmm.
It's 99.
Oh, okay.
I'll just put it in chat window then.
Yeah, okay.
Thanks. Night link with all of you guys. The file is still getting uploaded. I think this will take a good time. So, once it's uploaded, it will be appearing for you.
Yeah, okay, sure. It was good session today. We'll catch up tomorrow.
Sure. Okay. Yeah. You guys.
Thanks for your wonderful session, Shivank.
Thanks, Shivank. Thanks.
Have a great evening. See you tomorrow then. Yes. And Girish, please call me then. We can discuss about it.
Yeah, sure. I'll do that.
Thank you.